Plug it in. Good morning, everyone. Morning. I see our room is not very full at the moment. Where are your friends and your colleagues? At the waterfront. Okay, let's start the day off with some mind-inducing, some thought-inducing work. Those who are outside and can hear me, please make your way inside. Okay, yeah. Are we good? We ready? Oh, okay, we wait. Okay. Whilst everyone's just coming in, settling down, those who just joined us, please just scan the QR code, join the quiz. I do want to ask a question though, right? And this question, you just put your hand up if it actually applies to you. Who of us here are early morning risers? Who's a morning person? Okay, a few. 5 o'clock wakes me early, but I'm not a morning. Okay. So then we all like to sleep late, the majority of us. Now let me ask you this. Does your job let you just sleep late, or must you be on time to your job? You must be on time, right? Guys, we start 8 o'clock, no? It's 8:02. Okay, it's 8:02. Okay, African time, yeah. Are we all ready? We're gonna start. Quick 5-minute quiz. Um, 5 questions this time. Only 5 questions. Okay. First question. Ready? Okay. 10 more seconds. Okay, first question. Are we ready? Three, go. To prevent disease and support healthy aging, a life course approach to immunization, dot, 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 correct and fast. Okay, time's up. And correct answer? Three. Yeah, well done. Oh, okay. We ready for the next question? Which of the following statements is false? Three more seconds. And the following statement that is false. COVID-19 vaccine was the first ever vaccine to be manufactured locally in Africa. Okay, next question. True or false? Antibiotics can prevent and treat viral infections. 5 more seconds. And is it true or false? False. Yes, correct. Correct. Okay. Two more questions left. Next one. Which deadly disease was once known as the Black Death and now has a vaccine? And the correct answer? Plague. Is this those questions where we need to debate also? Let me tell you what, Beverly, no, I'm sorry. Okay. Okay, let's go on to the last final question. True or false? The RTS malaria vaccine is the only ever licensed vaccine against parasitic disease. And was that true or false? True. There was a divide. Okay. So, who was the fastest and correct at the same time? Who's getting one of the prizes? Layla. Well, for the second time now. Well done. Okay. I do have one announcement. Did anyone leave this in the venue yesterday? It's, I think, a hand brace or something. Was this left by anyone here yesterday? Okay. Okay, then. Now I'll hand over then to the chair, Ruzani.
Good morning and welcome to another exciting day today. I'm sure you've already been welcomed with the quiz in the morning. You're going to see a slight change on the program. Our two speakers this morning have swapped places. So the first speaker this morning is going to be a good old friend of VACFA. He's been in Cape Town for a very long time, although he doesn't come from this province. A medical doctor, UCT graduate, Dr. Mrena Makwana, who is the CEO of the BioVac Institute. Is that what you call it? Yeah. And this is quite an important issue that he's going to cover because we have actually hinted to this. I remember when I was talking about vaccine equity, the issue about our ability to sustain the continent's need for this vaccine if we have to get a level of equity and access to vaccines for those that need it in our continent. And that's basically what Morena will be speaking about. Please come forward, Morena. It's just to remember that this is in one of those roles that are very rare in the continent, that we don't really have a lot of vaccine manufacturers in the continent. This is what in the group of what we call developing countries vaccine manufacturer space. And so it's really a great privilege to be able to have someone here in town who can speak with authority in this space. Thank you very much and welcome again.
Thanks to Ruzan and thanks to VACFA for inviting us back. This is a very exciting because I think we go to many manufacturers, which is all fine, but I think it's always important that at least we share information. So I'm hoping that some information that we will be sharing won't be something that you are too familiar with, but I hope you've seen something and maybe you don't understand it, and I'm just here to really just provide some perspective to what's happening in the landscape, particularly in the last 12 months. There's been a lot happening. There have been a lot of headlines that you may have seen, and I'm hoping that I can just put some context. I don't have all the answers though, but hopefully I can just put some context in terms of what's happening with vaccine manufacturing. So this is just the outline of my presentation. I'm going to talk about just I think what is probably known a lot more about what was happening before COVID in terms of African vaccine manufacturer. And then the post-COVID when everybody wanted to talk about vaccine manufacturer. And then what's actually happening? What's the 2024 status? What should our countries be doing? And I'm going to make our own case study just in terms of trying to put a real case behind what we are trying to do as a company. So yeah, so let's see how it goes. So this is something, this is a slide that I'm sure will be very familiar to you. People use just different colors for this, but essentially our continent is what we call a very Gavi-dependent continent. So again, I'm sure many of you know about it, but let me just outline what it actually means, because maybe not everybody understands it, because some of you may be coming from countries that are not dependent on Gavi. So essentially the dark shaded countries there are the countries that are receiving support from Gavi and its donors. Essentially means that they pay very little out of their own fiscus, out of the pockets, to pay for vaccines. They do contribute, but the majority of what they contribute, or the majority of supplies and the financial support comes from this organization, mainly called Gavi. Now, Gavi, we normally refer to Gavi because Gavi is the one that is raising funds for these countries, but the actual procurement is done by UNICEF as well. So we use sometimes UNICEF and Gavi interchangeably. As you can see, the country that we are in now, being South Africa, does not buy from Gavi, so it buys vaccines out of its own fiscus. So the National Department have to budget together with Ministry of Finance and make money available for EPI vaccines or for any adult vaccines that may be used. But the majority of our countries are now Gavi dependent. What this means is that ultimately Gavi then needs they do their own pool procurement, and that's normally volume driven. But let's go through some of some of the aspects that that this relates to. So, have I skipped the slide? Yes, I have. Okay. So this is essentially what was happening. The picture hasn't changed much, quite frankly. I mean, since this slide was put together by WHO and others, just in terms of what's happening in the various regions. So what you'll see on the light blue top left is just the contribution of vaccine manufacturers. In actual fact, that 2% is less than 2% in terms of what vaccine manufacturing contribution is. And I think it was just highlighting where the headquarters are more than anything in terms of the volume. The bottom left shows you what the vaccines that are required, the volumes that are required, and what was being planned at the time in terms of manufacturing. On the right, I think, and that's what also I'll just try and outline in the next slide, is obviously with COVID, companies like Pfizer had a big market share at the time, largely because of COVID. But if you strip COVID out, which is your bottom right, it shows you that in actual fact, this market, this Gavi market, and the global market by volume is, there's one major player called Serum Institute of India, who is still contributing about 24% of the volume there. So if you strip COVID out. Again, the landscape is changing, but not too much. But this is still reflective of essentially what's happening. But let me just outline, just go a little bit deeper in terms of this procurement. So what you'll see here is, there's a split between volume and value. Okay, so when you look at volume, and this is really just to outline the contribution that India has had over time. And so what you see there in the blue is blue shaded is India's contribution by volume, and by value it's less, but by volume it's much higher. I think this is a picture that was put together in 2022, and I think value-wise this may have changed. Now I couldn't quite find the latest, but I think the red part. My gut feel is that it has shrunk a little bit in terms of the multinationals' a contribution to the red part, and because the likes of PCV10 have now kicked off. There's Rota from India, so I think if you had to take a slide of today, I think the blue side of this slide is a lot more. And again, companies like Serum Institute of India are major contributors here. So before I move on to what's happening on the continent, I just wanted to outline just generally, which I think is, I'm hoping that many of you know, that our continent is still largely dependent on procurement from Gavi. Gavi buys from the cheapest. They don't look at historically, until what I'm going to tell you now, they were very blind to where they buy. As long as you are WHO pre-qualified, as long as you are the cheapest product, they essentially didn't care where the vaccine comes. So if they want a measles vaccine and they want it at the cheapest, and they would buy. So that's how India got to have such a large market share in terms of volume. Now we know India is quite an industrialized country. We know that they've been manufacturing vaccines for a while, and they were one of the early takers when this WHO pre-qualification takes. So that is part of the history of what has happened. But whilst it has been okay and everything is good, I think all of us would know that even when COVID came, besides everybody blaming Pfizer, J&J, and AstraZeneca, and Moderna for not making vaccines available, and for them to give us costly COVID-19 vaccine. But I think the world woke up to the fact that even India, which even Gavi was reliant on in terms of supplying COVID-19 vaccines, had a ban. So the same India that we were hoping was going to give us the cheapest vaccines like they do with routine, they essentially instituted a ban. So that surprised many markets, and I think even Gavi a lot more, because Gavi had put all of the, many of you may remember there was this mechanism called COVAX, where money was being made available. It was given to Gavi, and Gavi was going to buy COVID-19 vaccines from all players. And a lot of the reliance was to go to India to get the vaccines out of India at the cheapest prices so that those can be supplied. But that didn't go smoothly because there was a ban. So essentially, that woke up, many parts of the world, whilst we were blaming Europe, but also you can see that our dependence, particularly on one large market or one large country, was evident that that is a problem. So what was happening then at the time in terms of vaccine manufacturers? So Senegal was looking at yellow fever, still less than 10 million doses at the time, and on and off production, but they've been at it since 1935. They've been busy manufacturing yellow fever. That's what they've been doing. They do diagnostics as well, but that's what they've been doing, and they were starting to think about expansion. In Egypt, an old manufacturer called Vaccera was still manufacturing vaccines. Even I think today they're still doing DTP for the Egyptian market, but they were doing their own activities. Our company, BioVac here, at the time, we had two tech transfers that were supplying largely to the domestic market. One we were working with Sanofi, the other one we were working with Pfizer at the time, but we were only supplying the domestic market because that was the contractual limitation that we have with the companies that we had struck deals with. But essentially, nobody else was doing much around vaccines at the time in terms of actual vaccines. I'm not talking about people that were talking about promises. I think Nigeria has been, every 5 years, there's been an announcement about Nigeria wanting to do something. So even at the time, Nigeria wasn't doing much. Ethiopia was also, they had facilities and we had visited them a while ago, but actually in terms of producing for market, nobody was doing none of that. So the issue is, in order to change the market, besides some of the issues that came with COVID, what does it actually take for an African manufacturer to really come to the party and to really get well established and to really run and be competitive? So this is a slide that was put by Gavi, and I'll talk a little bit more in detail about this mechanism they've now come up with. But at the time, when these bans came, when the political noise was, the issue was, how can we help African vaccine manufacturers? How can we make sure that they thrive? They looked at financial model. They were thinking about what is called an AMC. So what is an AMC? An AMC is an advanced market commitment. An AMC essentially says that I'll buy this particular vaccine for 10 years. So let me make PCV because that's probably the best known advanced market commitment. So when PCV vaccines came up, 2005 or whenever it was, PCV7 at the time and PCV10 from GSK came, there was a need for pneumococcal vaccines to be made available, particularly to low and middle income countries. Now, at the time, there were only two manufacturers, being GSK and Pfizer. But Gavi and the world needed a lot more of PCV vaccines. But how could they get the cost lower and to be made available? So they got into 10-year commitments with both GSK and Pfizer in what is called an advanced market commitment. So they essentially said to Pfizer and GSK, if you produce 30 million doses of vaccines at this, if you give us vaccines at this price, and at the time I think they started at just over $3. If you give us vaccines at this part, we will guarantee you to buy 30 million doses annually from each one of you for the next 10 years. Now, to a manufacturer, what does that mean? Okay, now I don't know what Pfizer and GSK means, but if somebody was to give me an offer now, knowing what I know about vaccine manufacturer, that's the best model, because what you can do is that you can go to a bank, you can ask anybody and say, look, I have a contract for 10 years, I'm going to be producing 30 million doses, so I have a guaranteed market, okay? So that I can go and put a lot more into my facilities. Now the price won't be high, but I'm going to sweat the assets being my facilities. That's what an advanced market commitment is. So many of us as African manufacturers, when this whole thing came, we wanted an advanced market commitment. But without an advanced market commitment, what you're seeing there in terms of the upper shaded graph shows you how much you need to burn if you don't have any of that promise. You have to burn a lot of money, and cash flow, people tell you that cash is king. You have to burn a lot more money before you actually reap the rewards. So the question is, African manufacturers don't have money. We don't have venture capital. Our billionaires are not putting money into the sector. Some of the vaccine manufacturers are state-owned, some of them are privately owned. Who's going to be funding that cash before you actually take off? And so it's been a problem. And so people are saying, okay, why is vaccine manufacturing now sexy and why is everybody talking about it? That's because somebody needed to take care of that, where it's really, where there's negative cash flow. Because who's actually going to fund it? The governments don't want to fund it. People, there's just no money. So that is the reality of African vaccine manufacturing, is that to get to the facilities of the scale that we need, you need the cash. And unless you have a market, how are you actually going to build those facilities? So that has been the limitation. So the model that was done at the time, and it's not yet the current model, but the model that was done at the time is that if you give an advanced market commitment and you say, okay, BioVac, I'll buy a cholera vaccine that you are developing and I'll buy it for the next 10 years, but you must provide it at this price, then it makes it better because we can then go and ask for good money. And the banks would say, and I'm not talking about commercial banks now, I'm talking about development finance institution, would be able to at least provide the cushion. So this is a little bit of the dilemma that we're in, and that also the world recognized and said, unless there's intervention, we're not going to get African vaccine manufacturing going. Now, we're talking about the levers that are needed. So you need the appropriate financial incentive. So I've just spoken now a little bit about the advanced market commitment, okay? So you need some of those things. Now you need partnerships, okay? So you can develop your own vaccines, but I'll tell you it's very expensive. As we all know, and I saw some of the topics, if you think about what an RSV vaccine or the MABs have cost Sanofi, Pfizer, and GSK, it's a lot of money. I think the RTSS vaccine at the end of, not RTSS, always get these things confused. Anyway, the upcoming TB vaccine, once it's done, I think it will be north of $2 billion from what GSK had spent and what Gates and Wellcome Trust are going to spend on a TB vaccine. No African manufacturer is going to take that type of risk, not at the current state that the economies of Africa are at. So a lot of us are dependent on tech transfers to partner with others. So that's an important lever. And ultimately, we need that demand. We need our countries to provide that demand. So it's a very difficult puzzle to put together. So sometimes we just think, okay, African manufacturers just get a vaccine and then get going, But it's in our context, it's not as easy to put together. So the sweet spot, quite frankly, and I think that hopefully we're all aligned in the room and in the virtual room as well, is that we want to be better prepared when it comes to pandemic, okay? And again, we make reference to pandemic because we had COVID-19, but since then, as we know, there's Ebola, there is now Marburg, there's Mpox. It's just never ending, okay? As infectious diseases are there, you guys are more of the expert than me. So I think when we look at pandemic, let's also put just outbreak response, okay? That I think our continent, we know that we need to have outbreak response, okay? Now, again, against that, we need a global healthy market. So we should not only look at our own countries, because our own countries individually are very small, and ultimately we need to be commercially viable. I think the last thing that we need, and I think South Africa has learned lessons from state-owned enterprises in other sectors, where government has put a lot of money, billions of money into state-owned. So, we need to have commercially viable manufacturers and not just state-owned enterprises that are just going to suck money and with little output. But somewhere there needs to be a sweet spot, and that sweet spot is very difficult to put together. Okay, so let's move on. Post-COVID. Okay, so out of all of the depressing things that I've now just described, there have been a few levers that have happened between 2021 up to now. So number one is politics. Sometimes I don't know whether I like politics. Sometimes I don't know whether I hate politics. All I know is that we can't ignore politics. Love it or hate it. And even what's happening in the US, you like it or not, we just live in that reality, Vaccines, and some of us are not political in nature, but unfortunately, vaccines are very close to politics because they're bought by public sector largely. The UN and the WHO and the Gavi, they're very political, so you can't. So on one hand, we may hate our politicians, but we do need them. But they did make a big noise and the right noise. That said, what happened in terms of the blockages, we can't just let this continue. So they put together what is called the PAVM, and I think it has a new name now. But it was a partnership for African vaccine manufacturing. And that was sort of, let's call it the political stream. Okay, that was saying, let's try and get this going. The financial mechanism is important because something needed to change. You know, there's no point making a noise and say we want to manufacture, but without putting the financial mechanisms in there to make sure that these African manufacturers get going. And I'll tell you about what was launched in June. And then lastly, who's actually going to be buying, you know, from the global procurers, but also the local procurers? How is all of that going to be coordinated? So from the political side, there's this ambitious goal that I think many people are still very skeptical about you know, our politicians saying that by 2040, they need 60% of the vaccines that are consumed in Africa to be made in Africa. My view about this is that, guys, it doesn't matter. 60%, 54%, 44%, 34%, but it can't be 1%. Okay, it has to be something double digit. And whatever we're going to get to by 2040, if it's not 60%, but if it's double digit, we would have moved the needle a lot. We would have moved the needle a lot. And I'll tell you about the reality that's now coming through. So I think it's very good. I think you must have a vision. You must have a stretched vision. And so I'm not complaining about the 60%. Whether we'll achieve it or not, you know, but we just need to move. And certainly not 1%, but we need to get into double digit. And I think if by 2040 we even get to 15, 20, 30%, I think we would have done a lot. Because once you do that, you know, there's just going to be a snowball effect. The snowball effect will kick in, other players will come, and then you'll come. But to get going, it's going to be difficult. I'm certainly, you know, and I have a vested interest in making this work. But, and again, I don't debate whether 60%, I'll just say that we need to get going. So once this came then, as I always say, that everybody and mothers, their cats, their grandmothers then came up and said, I want to manufacture vaccines, okay? I have the capability, I want to manufacture vaccines, okay? So this is what happened. So COVID came, and so remember the slide that I showed, there were only 3 players that were around, and a lot of us just then got diluted with all of this to say, oh, no, somebody wants to make a vaccine here. A lot of president announcements, and there were a lot of things that was announced. And it was great to some extent because, you know, I think Africa got attention from, you know, the likes of the EU, and everybody said, okay, what are we going to do? So to some extent, it brought good attention to the continent. On another, you know, there was skepticism to say, okay, guys, but I mean, really, is this realistic? Should every country want to manufacture vaccines? We know there's economies of scale. Who has the capacity? Who has the regulatory systems? Who has the skills? Is this really going to work? But essentially, this is what happened. A lot of the announcements then came through. I'll tell you where. Again, I'm slowly moving to where we are going. But let me go through this thing called AVMA, okay, which is the financial mechanism, and that's probably the best update that I can give you today if you're not close to it or if you've just heard about this. And in actual fact, I'm going to go into a little bit of detail in terms of how does it actually work. Now, I know a lot of you are either in the epidemiology phase or in the clinical phase. So welcome to the world of vaccine manufacturing and the difficulty of putting things together. So let's go through a little bit of finance. I'm not a finance person, but I'm going to tell you about this mechanism that Gavi came. So remember earlier I talked about the AMC, which is what we were hoping Africa will be given to say, okay, African vaccine manufacturer, if you get pre-qualified, you're going to get a 10-year window to supply this at this price and guarantee. That's what we were hoping was going to happen. There were a lot of negotiations. They came up with not an AMC, but an accelerator, okay? You can call it an AMA. And they actually termed it that way, okay? So an African Vaccine Manufacturing Accelerator. So this is, I'll be a little bit slow in terms of understanding this because if you see it for the first time, it can be very, very confusing. So it says, firstly, as a manufacturer, it's important that you just don't tell us that you have a vaccine and that we should buy from you as a global procurer. This is Gavi now, okay? Gavi says that I need you as an African manufacturer to have the same certification as everybody else, okay? And yes, your local licensure is important, but I want you to get WHO pre-qualification because that has been my standard from time immemorial, and therefore you need to get WHO pre-qualification. So as a manufacturer, go and do what you need to do. But firstly, before we even talk about any of incentive, you must get pre-qualification, okay? And then when you get pre-qualification, because we know it's going to be a long road to get to that point, we will give you a financial incentive, okay, before you even sell one dose. Just by getting to that point, we will give you a financial incentive, okay? And I'll show you on the next slide what those incentives look like. But I want you to be competitive. So I'm giving you a financial incentive to at least you have gotten to this point, but I want you to be competitive. So you still need to go and tender and compete with the India that you've been complaining about, and go and compete with the Pfizer that you've been complaining about, and the GSKs and everybody else. And you must win the tender. But if you win and you'll be competitive, because I know that it's difficult for you to compete against large markets, I'm going to give you a top up. Okay, so if you win X vaccine, and then I'm going to give you a top up. But depending on whether you're doing end-to-end vaccine manufacture or you're doing full finish, and depending on whether it's a priority vaccine or not, the incentives differ. Now I'm sure I'm confused the hell out of you guys. Okay, but I'm going to make sense in the next slide. But this is essentially what AVMA is about. It essentially says, I'm not going to give you any money now. You go and look for your own money, okay? To do your infrastructure. You go and do your own tech transfers. I don't know where you're going to get the money, but you go and do whatever you need to do, okay? You need to get pre-qualification. Now, the pre-qualification thing is very important because your local NRA, your local national regulatory authority, has to be of a particular standard before even PQ comes to look at you. So if you're from a country and there are sorts of what they call maturity levels, so you can have the fanciest facilities. I always make an example of Bangladesh. You know, there's a wonderful manufacturer in Bangladesh called Incepta, okay? We know them well. They're a large manufacturer in pharmaceuticals, and they actually do a cholera vaccine. And Bangladesh, if you just look at cholera, I mean, it's quite endemic there. Incepta has been there for a while. They manufacture vaccines. They can't export them to Gavi markets, not because they don't have the capability, but because their local regulatory authority is not of a standard that WHO can rely on it, because the PQ system is about reliance. PQ comes and they inspect you, but they leave you with your authority for pharmacovigilance, for GMP inspections, for all of that. So it's a reliance mechanism. So if you take a country like Bangladesh, or a company in Bangladesh, they can have all the money and they can do whatever, but until the regulatory authority gets to a particular level, they won't be able to export. So pre-qualification, so in between pre-qualification, what's not described on this slide is that you have to get your local licensure in a country, which is your own country must be of a particular, what they call maturity level. So guys, it's very, very complex. And I'll probably start speeding up now so that I can get a lot more questions. So let me continue confusing you guys about what looks like a very simple slide actually means in reality, okay? Because it's all nice coming up with models and slides. So this is what Gavi says. So Gavi says, look, I have priority vaccines. I have vaccines that I either don't have enough supply or they still need supply. The vaccines that I, as Gavi, feel that I need a lot more of, okay? So African manufacturer, I'm going to have that category of vaccine that if you have that vaccine, I'm going to give you a bigger incentive than the other ones. So what I call other Gavi vaccines are vaccines that are still eligible for incentive, but you get less of incentive. So if you come up with what is called on this slide, AVMA priority vaccines, and you come up with, and you get the pre-qualification, you're going to get a bigger incentive around there. Now, what are the incentives? So there's a lot of numbers that are there. So the first incentive is that if you come up with an mRNA vaccine, it's a priority vaccine, but use the mRNA as an example platform or viral vector. When you get to pre-qualification, you'll get $25 million. $25 million is a lot of money, guys. I'm sure you know that. If you come up with a vaccine that does not use mRNA, nor does it use viral vector, but is still a priority vaccine, and it's end-to-end manufacture, you're going to get $20 million upon pre-qualification, okay? But if you only do full finish, but it's still a priority vaccine, you get $10 million. So you can see the incentive is to address a need. The incentive is for a manufacturer to aim to have to be end-to-end rather than just full finish. But they're not neglecting full finish activities because those are important, and I can tell you a little bit more about it. And so even when you supply, if you're an end-to-end manufacturer, what you get as a top-up, which is 50 cents a dose, is higher than a full finish, which is only 30 cents a dose. Now, the whole amount that is being made available for African manufacturers over a period of 10 years is $1.2 billion, which is a lot of money. It's a 10-year scheme that was launched in June this year, and we still have to go through. So maybe I'll just wrap up. So it was launched in June in Paris, and it was nice, wearing ties, having croissants there in France. And a few manufacturers were announced that were doing deals. So our own company, we announced a deal on a meningitis vaccine. Not our own, but we were working with a company in South Korea called U Biologics. We also announced a second deal with Sanofi on an inactivated polio. And then we also gave them an update on our cholera vaccine that I'll touch on later. And then these are the other announcements that were made from a company called Ghana. Senegal also updated in terms of what they're doing with their yellow fever production. So this is what AVMA is about, guys. And essentially, it was launched in June this year. Before I move on to what's happening with the manufacturers, I thought it is important about the scheme that I think it's the if you ask us as African vaccine manufacturers, whilst we wanted an AMC and we got what they now call an accelerator, we would have loved an AMC, okay, but we didn't get it, okay. But now we have an accelerator, and I think from how it's designed, it's not a bad design. I think we can live with it, okay. What is challenging though, and that's where we are trying to tell Gavi. So Gavi has put a 10-year timeline, and they launched in June. No manufacturer today is going to sweat the 10 years because no one is pre-qualified today. Whoever has made announcements is in tech transfer or you're in development, okay? So the best, if they don't ever move the timelines, the best that this scheme will actually be able to be utilized is probably 6 years, okay? Probably 6 years. So what's a 10-year scheme? But the best, and this is the best, assuming tech transfer assuming license goes well, is probably going to be only about 6 years. That actually they're going to be able to use it and disperse money. And we are actually not even sure that they will disperse all of that money from what we know today. Things can change. So we love it. We're not complaining, and we need to sweat the asset. But I think there has to be some reality kicking in, and we have lots of engagements with them. Okay, guys. I'm not sure how much time I have, but I know I need to move on. So okay, this is something that has come up in last month in October. From Africa CDC in collaboration with CHI, Clinton Health Access Initiative, and PATH. So what they are doing is that they are saying, look, there'll be lots of announcements, okay? And who is doing what? Can we just categorize who's doing what, okay? Because it's one thing saying that, you have a car, but if the car is just sitting at the back of my yard and weeds are growing and even rats are even going there, is it a car? Is it a taxi? What do we actually mean by a car? Okay, and so they went around and actually visited, and they visited a lot of us, and they put us into categories. And this is published. This is in the CHI website where they have this. So they say they've broken us all into 3 segments. So the segment 1 is the guys that are doing this segment 1. Those have tech transfers underway that are doing something. So you'll see that there's a company called Mabio in, I think Mabio is in Morocco. There's Vaxera in Egypt. There's IPD in Senegal. There's Aspen here locally. And there's our company, Biovac. Those are companies that are doing something. Okay, that are actively doing something. And then there's segment 2, which is a segment that there are facilities that are there, but the facilities are waiting a tech transfer. They're either being signed up or or haven't been signed up, but the facilities are there. Okay. And then there are those who either are building facilities or have initiated, so you can see that's sort of like the color coding that has happened there. And so this was something that I think, so it's sort of like a similar slide, but just put differently. That says, out of all the 30 plus announcements, who is doing what and who is doing what in which status. So the logos that are there being BioVac, Aspen, and Vaccera. Vaccera is in Egypt. So we are actively doing something, but also we are in ML3 countries. This is where the status of the regulatory I spoke about, where you're in a country that has the required status to get to pre-qualification. So Egypt and South are ML3 for vaccines, okay? Now, Institut Pasteur Dakar, our friends in Senegal, are not in an ML3 country as we sit today. But I think there's a lot of confidence, and we spoke to WHO. In actual fact, we had a meeting with WPQ in this very room in early October. And I think IPD is going to get there, Senegal's regulatory authority is going to get ML3 in probably the next 12 or 18 months. So I think they are well down that path. And then you'll see there are a lot of logos there that are coming up in terms of people are either completing facilities or they are doing something. So essentially, guys, we're narrowing down to a lot of the announcements that were made, and the assessments is who's actually going to get to the finishing line and how are these AVMA actually going to be used up. So in addition, and again, this is also on this study that was done, it's said between now and 2030, who are for those that have been announced or who is actually likely to get to pre-qualification and to be able to supply? Now, there are those 8 vaccines that are there, and there are the country logos that are there. So the country logos, certainly from South Africa, is BioVac, and those where we have the asterisks. And then Aspen has the rest, and then we have our friends in Senegal being IPD. So essentially, they're saying that a lot of announcements, a lot of all of these, the facilities that are being built, but who is actually likely to have vaccines that are pre-qualified and supplied to Gavi by 2030? Okay, now, this is not for me. You may say I'm biased, but this is what Chai Africa CDC went around and actually assessed. Now, so firstly, I think it is accurate just from our own market intelligence and from what we know. But I think in the next 2 years, if our friends, let's say in Ghana, do what they are going to do, and the regulatory authority gets, I think they're probably the next country that, if you have to ask me, that may be added to this list. But this is sort of like as at today. So, okay, so let's move on quickly. I talk a lot, guys, so I need to be stopped at some point. Okay, so so we've spoken about Gavi, okay? What Gavi is doing and all of this. We've spoken about manufacturers and what do they do. But what are our own countries doing? Okay, so it's important that Africa also plays its part and say, I need to buy vaccines myself as an African country, and I need to buy from African vaccine manufacturers. Because one thing us going around shouting to the EU, going to Geneva and shouting there, at some point we must shout at ourselves and say, what are we doing ourselves to make our own capacity for manufacturing available? So Africa CDC have started an initiative. It's going to take long. It's normally called the triple PP. I always get this wrong. Pool procurement. There's another P. Pool procurement, whatever mechanism. Anyway, so it's about pooling procurement, and essentially for African countries to commit to buying from manufacturers. So as much as we're saying Gavi must help us, and they've come up with a mechanism, Gavi says, and the donors have said, I've done my work, okay? You manufacturers must do your work, but the question is, what are the African countries going to do themselves? So AU is starting this initiative. It's not going to be easy, guys, but it has to happen. Our countries need to buy from African manufacturers. And yes, there are price sensitivities, there are all of those things, and I'm sure we can find a middle route, but we're not going to get to 60% and beyond if our own governments don't put their 2 cents worth, okay? And so they started this. There was a market thing that started, what we call market placing meeting that started last year to talk about pool procurement. Africa CDC have identified countries. They're actually doing a country visit to South Africa in the next 2 weeks to talk to South Africa about their readiness and their willingness to get into this pool procurement. So what would this do? Just to come back to, and this is just Africa CDC's model, but this is a year ago, but it's, you know, it may not be that accurate, but I think it's more symbolic than anything, that ultimately we want to get to 60% of vaccines made in Africa, 60% of what we use in Africa being made in Africa. But initially, there's going to be a high cost. So everybody has acknowledged that it's going to come initially at a high cost, which is why we need the incentives and all of that. So the graph that you see that's going down and left on your right, it shows you how, if all of these things come together, how African manufacturers can get to a low-cost scenario. Because we've always been saying, but yeah, you guys are not competitive. You guys will never compete with Serum Institute. You guys will never do this. You know, there's been all sorts of negativity that have come through. But unless these mechanisms come through, and people have modeled, I mean, this is financial models, and we know ourselves, if we get to the large scale, if we ask me today, we are not competitive. But we have a model that says, if this comes to the party, I'm very confident that even us as BioVac will be competitive in the years to come. So African companies can be competitive, but it's that initial element that needs to get case studied. So guys, I'm going to just finish off with our development of cholera vaccine. I think Bev may have touched a little bit on cholera, but I'm going to tell you how, in a real case study, how does this come together and the pain about this. I think last year I was asked in this forum, but why cholera? Really, why cholera? It's like, oh, it's boring. Why didn't you go for something sexy? You know, malaria, TB, RSV. Okay. And so firstly, cholera hasn't gone away, as I'm sure you all know. Okay. It's becoming endemic. In actual fact, instead of, I think WHO and everybody has acknowledged that instead of having these outbreaks, let's actually get into preventive campaigns and let's have a 10-year forecast so that manufacturers can actually invest in it. And I'm sure you know that, as we said today, there's only one manufacturer of cholera vaccine, and we're all susceptible to cholera. Even our own country has had its own touch of cholera. We know it's certainly endemic in the likes of DRC and other places, and other places are actually not even reporting enough. Okay, and as they say, if you don't look for it, you won't find it. I mean, like India is a case in point. I mean, a lot of people believe that India has a lot of cholera, but it's not spoken about. But we know it's there in Pakistan, it's in Bangladesh, and anyway, is a needed vaccine. But I'm taking you through the realities of getting to end-to-end vaccine manufacturer using this as a case study. So we partnered with IVI, International Vaccine Institute, that's based in South Korea. And they've been developing cholera vaccines for a long time, but they're not a commercial manufacturer. They develop platforms and technologies, and then they outsource it. They've been in oral cholera vaccine. So we got the base technology from them. Okay, so what did we do? So the reality is that, okay, you go to South Korea, they teach you, okay, this is how we do the oral cholera vaccine. But they give you at small scale because they've only gotten it at small scale. You then have to fly back to South Africa, go into your own labs and say, okay, I've been taught how to do it in a small scale. I now need to do it in a small scale in my own facilities. Before I get ambitious and before I get excited, I need to show that what I saw in South Korea is actually what I'm doing. Okay, now that takes time. You do it and you say, hey, I can do it in 15 liters. I'll show them how to do it in 15 liters scale. I'm doing it in 15 liters. Okay, tick a box. It means you can, what you are shown, you can do. Okay, just like how you did in surgery. For those of you that are in medicine, before you actually go and, you know, you need to observe and you need to get there, you need to supervise, similar mechanism. Then after that, IVI has done its job. Okay, the rest is up to you. Now you say, my word, I need to get to 200 liter scale. How am I going to go from 15 to 200 liter scale? I always use a simple analogy of coffee and say, let's assume that you like your nice strong coffee, okay? And you know, it's normally, obviously the smaller size will give you the nice strong, but what if you have to do a drum of coffee, but it has to taste the same as that concentrated one. Now, how possible is that? Now, I always use that analogy as scale up. Scale up is difficult, okay? So we've had to, between we started 2022, 2023, we were going from 15 liters and going up to scale, and we needed to get to 200-liter scale, which we've achieved only in the past month. And there are two strains that you need to do, Ogawa and Inaba, and that we're doing. And so we need to get to that scale, 200-liter scale of those two strains, and we need to do that. Now, within that, it's not only about the scientists having fun. You get it to a particular level, okay, in a non-GMP environment, okay? So that's where the scientists are having fun. It's less regulated. Then you have to take it, because you take it to clinical trials. You have to take it now into another facility, okay, that you need to have to now you comply with GMP to show the regulator that I want to get into clinical trials and what I'm producing is safe. So you're dealing with a few things, okay? Firstly, you're dealing with upscaling that nobody has taught you, okay? Remember that base technology is gone. You have to deal with multiple facilities. Not only this facility that you need to experiment and have fun, that you have to maintain, you have to get it into a GMP facility that is even more costly. The people that are experimenting, you don't want them on this side, because those that are experimenting will be fun. They won't even have gloves on because, you know, they're having fun. Okay, so the set of skills that are in the GMP are not the set of skills that are that we're doing the initial scale. But there has to be synergy, because these guys need to understand the scientific basis. The ones that are doing GMP have to understand the scientific basis of what the guys have developed, okay? And they have to work within the rules, okay? So there's a bit of synchrony that has to happen. And then you have to invite the regulator and say, regulator, please come. I want to go for clinical trials. And they say, okay, what do you want me to come? I want you to come to inspect for GMP because it needs to be safe before it goes to subjects. Now, this is about drug substance. I'm talking about the evolution of drug substance, okay? So that's what we are doing, and you have to get an inspector. Now, the regulator, you must remember, in the context of South Africa in this case, and I can talk about many African manufacturers, haven't inspected a manufacturer that has developed a locally made product. It's a very important aspect, guys. The regulator, they regulate, they go all over the world, but they haven't inspected their own companies for a product that was developed locally. So the regulator itself has to put its stamp first. Normally they go to India, they look at, but the Indian regulatory authority has done it. They'll go to somewhere, FDA has already done it. They're just doing their own. Now they have to come and say, BioVac, what have you done? They have to understand the science. They have to look at the facility and say, okay, you want to go for clinical trials, okay, and I'm going to put my stamp first. It's a major development, even for the regulator. Okay, so in this process, the regulator has to undergo this, and we actually got an inspection in October. Touch wood, we're waiting for the outcome in the next few months. And then you have to go for clinical trials, which I won't go into details, that you guys know a lot more of, which we are planning to do next year, and we will be working again with IVI and MRC, and ultimately get to WHO pre-qualification. So whilst we're all looking for the product, that vial that we will get, and we're either going to squirt it into the mouth or you're going to inject, the development comes through. And obviously multinationals and everybody goes through this, but I'm talking from a real African experience about what we are going through. And the question is, where's the money? Before we get to licensure, and this is a low cost development. So these two blocks before you get to licensure is going to cost us $36 million, okay? $36 million. And we're doing a phase 1/3 trial because some of the development has happened globally. So at least we don't have to go through a step, phase 1, phase 2, phase 3. So this is getting to $36 million. We don't have $36 million. We don't have $36 million, okay? We have facilities, I have expensive people that are there, 350 people. Last year, I lost a tender, PCV13, to an importer. A lot of other things that we're thinking, are not sitting with $36 million. And if you want to go for even more complex vaccines, you're looking a lot more for that. But this is what, and we're actually currently, we haven't even got it, we're at $20 million now. We have $16 million to go. So any rich uncles, please, if you have. Okay, guys, I'm about to finish. But why am I passionate about this? Okay, about oral cholera vaccine in particular? Because, okay, firstly, we can talk about it, we know about it, but I think it's a real life example of what an African manufacturer has to go through if you want to be end to end. Always, people have always said, oh, fill finish, fill finish. Fill finish is complex. But okay, if we want to go from fill finish to end, it takes time, it takes resources, and it takes a lot of money. But anyway, if we get this right, and by 2027 we should, at least we would have been starting to address a relevant disease. As you can see, the base technology was coming from others, so you need to work with technology transfer partners. You as an African company, you need to be able to understand where your limitations are. So, as a company, we also want to delve into mRNA, but you can't be anything and everything to everybody, So we're not like, as an example, the viral vector platform, we're not the strongest, but bacterial vaccines were quite strong, okay? But you have to seize the moment. You need to have willing funders. So there have been funders that have given us $20 million, and hopefully we can close the $16 million in the next 6 months, or else I have staff that are panicking. And then is the environment. So in terms of Gavi and AVMA and what I've described, and ultimately what I've said is the regulatory system. So it's one thing to look about manufacturers, one thing to look about systems, but you have to look at the whole ecosystem. And so what cholera, I'm hoping, can be a case, not only for us as BioVac, but hopefully for the continent, is to be able to put all of these cases together where we need our regulatory authority to be ML3. I need our scientists to still be engaged. We need to raise money from the money that we don't have. We need to have tech transfers. So it's really all about that. So where does it fit in as an example? So oral cholera vaccine is a priority vaccine in terms of the Gavi AVMA. So at least we're in the right category. If we get things right, we'll be getting $20 million. Because it's not mRNA or viral vector, we'll be getting $20 million when we get pre-qualification. If we win the tenders, then we'll be able to get a top up on the price that we would have offered of about 50 cents, a dose, because it will be a single dose vial. And that's how I'm hoping you understand this very, very complicated mechanism that has come through. So ultimately, we want a project that would preclinically would have been developed in Africa. We want to clinically to be tested here. We want to be manufacturing from start to the end here. We want to make sure that we attain the highest regulatory standards. We don't want to be questioned about our standards, and ultimately want to address an ongoing need. So, so wish us luck in the next few years. Hopefully we can say we have a product that was developed here, tested, manufactured, and supplied to the world. Sorry for taking time, but thank you.
Thank you very much for that, Morena. I actually allowed him to go slightly longer because I know that this is not the kind of information you would otherwise normally just readily be able to get. So we don't have a lot of time for many questions. So I will probably ask and limit this to very clever questions only. So let's see who's first.
I've got a stupid question, Morena, and thanks very much for a wonderful presentation. I think the audience here, there may be one or two who are involved or would like to get into vaccine manufacturing, and I think your talk was great to put them on the path. But I think more importantly, there are a number of people here who possibly operate in the regulatory framework. And I was just interested to see that you were saying that as part of the pre-qualification process is that you have to reach a maturity level of about what's classified as 3, okay? And of those 10 countries, because at the end of your presentation, you said only South Africa and potentially Ghana.
At the moment,
ML3.
And Egypt.
And sorry, Egypt. Yeah. So the other 10, what are they doing with respect to attaining that level of maturity so that they don't land up in the Bangladeshi experiment?
Good question.
Thank you.
Should I answer that? Okay.
Please answer. And yeah, no, that's not good enough.
Greg, your question is fundamental to the reality of all of these announcements. And it's a worry. In this room, beginning of October, we had the regulatory authorities that are ML3. We got those that are aspiring to be ML3. We got WHO, PQ sitting here, and we had the manufacturers. The manufacturers in those countries, those that have real initiatives, are sweating. They're saying, I think I know where I can get the money, but the money is dependent on us or my country. So there's a big worry. So I don't have a clear answer about those countries, but there's a big worry to say, I can put up my facilities, but it's unlikely to happen. But I think what WHO explained to us is that besides South Africa and Egypt being ML3 now, they are possibly, from what they can see, Senegal is definitely going to come through in the next 18 months. Ghana, they are positive in the next few years. I can't remember what timeline they gave. And Rwanda is also going to come through. Now, about the rest, I don't know.
Thank you. One online in the meantime, while I'm passing the mic here.
Okay. We have a question from Festus. He is asking, what is the political willingness in funding manufacturing plus research and development, also procuring from African countries to make it commercially viable?
Oh, my biggest pain point. I hope there are no politicians here. The simple answer is that there is no R&D money coming from African governments, okay? Firstly, we're not allocating money to research. And I'm talking research widely, okay? And those that are where the research is being done, I can't even remember the stats for South Africa and what DSI's budget is, but I mean, it's in the lower single percentages. Sadly enough, we have a case. I said that we need $16 million. We went to one of our funding agencies called the Technology Innovation Agency and asked for money to support this cholera vaccine. Unfortunately, they said no. So living case, this is what's happening in South Africa, unfortunately, yeah, and it's very sad, I must say. So we end up going internationally to get that. We're now, continuously being supported by international. And at some point, I think we need to start with procurement. At some point, we'll need to get to development before we go to research, because there is a difference between development and research.
Thank you.
Okay, thank you very much, Ndate Morena, for a beautiful presentation and for the insights. Really, for me, I really enjoyed and I appreciate the insights into sustaining the local manufacturing. Just one question, in terms of the ambitious vision of the AU of assisting local manufacturing, in terms of timeline, what is the plan for them to say maybe by a certain year we want to make sure that at least 60% of vaccines are manufactured locally? Yeah, thank you.
So the simple answer is that there's just a big aim, which is 60% by 2040. Which a lot of people have questioned and said, but how are you going to get there? So now they're actually working through how are you actually going to get there. So on one hand, they said, we need global support. Okay, so they went to Geneva and they said, we need support. Gavi said, okay, I'll give you support, okay? And then, and there are all sorts of other levers, but they're actually working through the actual mechanism. So it's not like there's a clear 2027, 2029, and, they are still working through that. At the moment, it's still an ambition, but they are trying to work hard and trying to balance global procurement, local procurement, and then tech transfers. They're also trying to support us on tech transfers. But yeah, the finer details of the AU, in terms of step-by-step getting to the 60%, it's not that crisp, to put it bluntly, but they're doing a lot of work.
One online.
We have a question from Dambe. He's asking what determines which manufacturer produces which vaccine. And he's saying, considering the African context.
Very good question. Okay. Yeah, so it's a very good question. I'll tell you. So in the ideal world, people have said all these announcements and all of those things in countries, they said, you manufacturers, let's assume that we're all sitting here. You manufacturers, you must decide. You must decide you are going to do this. You must decide that you must do this. You must do so that you guys don't compete for the same. Now, it's all nice saying that, okay? But I mean, and all of us are coming from academic institutions. Are you just going to tell some university that they mustn't have a humanities faculty? Or are you going to tell them that they mustn't have a medical faculty? I mean, so life doesn't work that way, okay? You're going to look at selfishly, what is it that you can do yourself? And whether you'll be able to compete. Now, there has to be sense because as an example, and I'll make an example, just in South Africa, in terms of the announcements, ourselves and Aspen are targeting one vaccine that we will be competing with, which is meningitis vaccine. So they've signed up with Serum Institute to do a full finish of a 5-valent meningitis, the one with X. We've signed with U Biologicals in South Korea. Okay, so you guys, you're South Africans, you're fighting for the space. Does it make sense? Why don't you look elsewhere? It's competition, okay? We think ours with U Biologicals will be better because it's fully liquid. There's not a fully liquid. We think the market wants a fully liquid, and time will tell. But it's competition, okay? Now, on the others, we'll obviously be looking sensibly in terms of what do you, but you have, as a manufacturer, you must make your own decisions. If you want to be competitive and you want to go there, you must be allowed to go there. But at some point, yes, I mean, there's some things, and I'll tell you one that is that's quite challenging for many of us, Mpox, okay? And I'm not sure whether Mpox was spoken about. Mpox is there today. There are these clades. We're not sure what's happening. We're not sure whether it's going to come and go. A lot of us had excitement and pain with COVID, which there's a lot of volume. It was a pandemic. But there's a lot of aspects about Mpox to say, guys, didn't we learn from COVID? And manufacturers, what are you going to do? So what do you do as a manufacturer? Mpox is not on the list of Gavi. So are you going to get incentive? Okay. But your heart wants to do it, okay? Where are you going to get the technologies? Okay, there's a Japanese company and there's a Danish company. Are they willing to do it? Okay. What are the guaranteed volumes that I'm going to actually be looking at? Can somebody guarantee me these volumes of Mpox? It's on my continent. I want to help. But can somebody just tell me that if I'm going to invest 3 years and a lot of money doing Mpox, please tell me that you're going to buy this vaccine? Okay. The reality is that, as we said today, those are not being answered. And we are a lot of pressure being put not only on us to say, guys, can you do something on Mpox? That's the reality. It's not like companies are not willing, but if I have to look at diverting resources from OCV to Mpox, I'm not sure today whether you guys will agree that I just probably must focus on OCV, have a test case, prove the test case, show that it works, and then maybe I can go to others if I want to get to end-to-end. It's a very, very difficult because your heart wants to be there. Your head is saying, but how are you going to pay the bills? So that's the actual reality. And again, this Mpox is not a competitive answer, but it just talks about the reality of we want to address these needs, but the mechanisms are just not in place. But the stakeholders know all of this as well.
Thank you. I know that there are a number of people who wanted to ask other really amazing questions, but unfortunately we have run out of time, and I look at my good friend Sipho there who's itching to come to the fore. So thank you very, very much, Renan. Really appreciate the time. Are you still around for a short while, or are you have to?
Unfortunately, I have to.
Yes, Ron. He needs to get the other 16 million. But you probably can talk to Bev, who works with Morena, and you can probably get some of the questions answered, because so when you see Bev during tea time, please do have a chat with her, and she'll probably be able to answer a number of the questions that you may have.
Yeah, as one as much is disappearing, but I mean, maybe between now and tomorrow, even if Bev cannot answer all those questions, she can just collate the questions, and hopefully even by the end of tomorrow, we can try and just answer them as best we can. So us not being physically in the room doesn't mean that we won't be able to answer your questions. Thanks.
And he does use the royal we. That's what the us means.
So remember, I said to everybody, have a look at RVR. And then I also said to everybody, look at the Lancet publication on asthma. And those were on my slides. The references were there. And also have a look at U Biologics, because that's the only market cholera vaccine in the market now. That'll also give you, fill in some of the blanks.
Thank you very much. And I really, again, appreciate you being here, Morena, today. So I'm introducing Sipho before the tea break. I hope you won't interfere with your tea break too much, but anyway, tea is overrated. So Sipho is an associate professor in the Department of Medicine, and he's
I think that's
he's a physician, infectious disease specialist. And And the important thing about him being here, which I think is really key, is that most of the time when we speak about immunization and vaccination, we tend to speak about children. And the important thing that SIPO addresses is this idea of unlocking the full value of vaccines by seeing their real impact throughout one's life. And that's basically what SIPO wants to talk about today. Welcome, SIPO. SIPO is a part of our extended VACFA family. Thank you.
Thanks, Ruzani, for that, and good morning to you. And thanks, the organizers, for asking me to come and speak to you this morning. So my task really is to try and hopefully by the end of this, just before you close your eyes, is that you will see the value of life course vaccination. That means, as Ruzani was highlighting, that we shouldn't be talking about vaccinations just only in childhood, but really seeing it throughout one's life. And my task really today is to show you that life course vaccination is part of the greater agenda by WHO in terms of healthy aging and how it fits in also the framework of SDGs. So what I will not necessarily do is to give you a immunization program per se for countries, but really give you high level. And hopefully those of you who sit here and are policymakers will really advocate for that to become policy in your country. So what I'm going to try and do this morning before your tea break is probably make two or three important points. One is that vaccination is an equity issue. I think two is that vaccination has economic benefits, right? And then I think three is to say that vaccination is about health and healthy aging. Hopefully, those 3 points do come through in my talk. So I just want to make these disclosures. As you can see, I'm quite promiscuous, and just note that I love them all equally. But that's me. But really, I think this is the more important disclosure. One of the things about I think vaccines you realize is that vaccinations are important for poor people. Vaccinations are important in this issue of equity, and hopefully by the end of this, you'll really appreciate that. I think Ruzani just told me this morning that he's shared you the statement by Stanley Portkin, only to say that I think as an intervention, vaccinations has been the one thing where you get value for buck, so it's value for your dollar or rand you spend. The other thing is that I think vaccines have been the one intervention that have really leveled the playing field. But frankly, it has taken us quite a long time to get there. And if you look at the greater scheme of things, vaccination programs have really achieved, in terms of preventing deaths, 154 million deaths. So a key intervention. One of the things just to say is that you'll appreciate that vaccination, especially childhood vaccinations, have contributed to increased life expectancy globally. And that's mainly through aversion of deaths. And the question, I think, is how much longer can humans live? So I think you can see that every country is experiencing increases in life expectancy. I think it's great to live to 154 if you can. The question is, if you do live to 154, are you going to be living to 154 healthy? That means, are you going to be functional? So do you want to be 154 who's functional or 150-year-old who's dysfunctional? And meaning dysfunction is that to the extent that you need somebody to look after you, even for the basics of your human existence. And the question is, if we're going to get to 154 in a healthy manner, you can't exclude vaccines as part of healthcare in that manner, because vaccines, and hopefully I'll show to you in some slides, is that they are going to help achieve this issue of healthy aging with functionality. Because many of the infections or diseases that you will get, especially infections as you age, impair on your functionality. So hospitalization for influenza, you may survive that, but leave hospital with respiratory problems, as an example. The other thing just to say is that this country, when it comes to pneumococcal vaccination, has actually been part of that 100-year experience. You will probably recognize or not recognize or aware that pneumococcal vaccination was first as a vaccination strategy discovered or tested in South Africa, especially in Johannesburg in the gold mines. So we've had this 100-year experience of vaccination, and I think the frontier is expanding. I think we're in the golden age of vaccination currently. So I've put that in terms of vaccinations, but vaccinations also do a number of things. Certainly, our experience from childhood vaccinations is that vaccinations have prevented a lot of hospitalizations, a lot of deaths, as you can see, but also there have been this economic benefits as well, and also this issue of drug resistance that we've seen. So just to highlight, it's not only preventing infections and these diseases that we worry about, but also vaccinations have had these other consequences which are good for society. And this next slide actually just captures that. If we are looking at the next threat, global threat, that is going to be antimicrobial resistance. And there's really good data and evidence to suggest that vaccinations play a key role in that. And one of the roles it does is that obviously if you vaccinate for, say, rotavirus infection, if children are not getting that diarrheal illness, they're probably not also getting antimicrobials prescribed for diarrhea. And if you talk about influenza vaccination, again, data in adults in Germany certainly have shown that if you vaccinate during the flu season, you also reduce the amount of prescriptions, unnecessary or prescriptions for people who use antimicrobials to treat flu. And you know that you don't treat influenza with antibiotics. I think that was part of your question this morning. So certainly the value of vaccines in terms of some of these issues I've mentioned is high. The one thing also just to highlight in terms of the benefits. So low and middle income countries actually, when it comes to reduction in prescriptions, for example, for some of these vaccine preventable illnesses, you will see that that greatest benefit has happened in low and middle income countries. So it probably shows you that also, even if your health infrastructure is very poor, by having a very good vaccination program, you can have an impact on health. This is just data from the US. It's modeling data. Again, just trying to show you that when you look at the economic burden and cost, either indirectly or directly, because of these 4 vaccine preventable illnesses, you can see some of those huge projections in terms of cost to that healthcare system. And this is just data for people who are 50 years and older. So certainly you'll realize that the globe is experiencing this boom in aging. So I think since 2012, the number of people above the age of 60 has more than doubled. So I think in about 2012, you were sitting at around about 11%, 10% of the global population that was more than age of 60. Now, as of 2024, that is sitting at certainly at 22%. In fact, there are more people older than 60 than there are people less than 5 years of age. So you can see that there is this global shift in the elderly. And the projections are that I think currently at the 2020 estimates that you've got 1.4 billion people who are age 60 and above. And in 2050, that's going to be close to 2.1 billion. So you'll see that this population of the elderly is going to increase, and you need to protect them. And certainly vaccines are going to be part of that program. This is just, again, some aspects just to show to you about some of these value adds that vaccines have had in terms of society. So not only just economic value, but also when you look at things like the impact on equity AMR and certainly cost effectiveness, you'll see that the data is beginning to emerge. This cartoon slide is data from 2018, and there's more and more studies actually showing certainly economic value and societal value of vaccination. So certainly great benefit of vaccination when you just look at these vaccine preventable infections. And I think these are just key in the elderly group, and hence I've just shared this slide with you. So you'll see that there are gaps, and the gaps, we do need to produce more data, just again to show what the evidence value add of vaccines are. And I think if you ask me about the impact on quality of life and carers, certainly I think you would be able to demonstrate that by choosing any of one of these vaccines that we use in people who are old and elderly. And certainly we just need to generate the data to show that impact. This slide just, again, is 2018 data, just to show you that there is certainly probably a growing appreciation, but certainly that appreciation hasn't translated into national programs of adult vaccination. And this data just shows you just globally where and which regions in the world are reporting or saying that they have national programs for adult immunization. And in this one particular Africa, there were no countries that reported that. Now, you may disagree with that, but I think it's just depending on how a country says they've got an adult immunization program. I think it's easy when you say, does country X have an EPI, because we all know what an EPI program looks like and the things it needs to have. Now, just because you've got a guidance document on influenza does not necessarily mean that there is a country program, because I think a country program speaks about access and how I'm going to get vaccinated for influenza, for example, who's going to do it and how it's done. So certainly as a region in Africa, I think we've still got a long way to go in terms of adult immunization programs. This is just from the same data. You'll see South Africa is listed there. And if anything, what they could pick up here from the researchers was that at least we were quite clear about influenza vaccination as an adult program in South Africa. That's all well and good, but I think when you look and see what are the vaccination rates in South Africa, then again, there are going to be challenges. If you look at the US data, which I was sharing with you in terms of even the vaccines which are indicated in the elderly, so the zoster vaccine, pneumococcal vaccine, pertussis vaccination, you'll see that even in the US, their vaccination rates do differ. So when you look at a vaccine for influenza, you'll see that the acceptance rate or coverage rate is around 70%. But when you look at the other vaccines, such as pertussis or even, for pertussis, you'll find that the data shows the coverage is at 20%. So not all vaccines, even if they're in-country program, have the same coverage. So it's also about challenges within systems about how you get programs to make sure that all of those who are eligible for vaccination get the vaccines that they need. So this is just to say that when we talk about immunization beyond EPI, we're not talking about special groups. We're talking about all of human life. And hopefully I will show you a slide which tries to depict that. And there are going to be key vaccines for different groups, yes. So certainly it is to be aware that there are going to be special groups that you need to be aware of. So healthcare workers are going to have particular vaccines that they need to have given the environment in which they work. And then adolescents will also have their vaccines, but it is all those stages of life that are important. And there, for example, maternal vaccines, which you probably have discussed or going to discuss, have particular vaccines which you want to address during that. So the next couple of slides really is about how do we frame adult immunization or life course immunization in the global health agenda. And really, it's all about achieving healthy aging. And there's been a number of work streams at WHO level and other levels where this issue about healthy aging is beginning to be recognized as an important health issue. It's an important health agenda. And certainly, vaccination through one's life course has been seen as an instrument of health equity and achieving healthy aging. And it's just important to note that life course vaccination is intersecting with a lot of these things. So, for example, it's part of SDG 3, and you'll see that SDG 3 features in a number of these health agendas. So it's also about the social environment, which determined health. It's all about, again, the principles and access of human rights. So life course vaccination is being seen as an instrument to certainly foster healthier living and access to some of these fundamentals for life in the world in which we live. But it's easy just to say that. So how would you then do that? And there have been a number of papers which try to look at these policies and how then do you put it into practice. And this, I think, if you're certainly a health policy person and are working in the vaccine space, I think is a good policy document to read, because it talks about this framework about life course approach to vaccination and how you would begin to implement and why it's important. And I think the issue here is just about ensuring that people age in a way in which maintains their functionality and capacity to live their life to their fullest, right? And and again, by doing that, you'll then allow people to realize all these other important tenets of healthy living, so access to human rights, equity issues, et cetera, et cetera. And I think what it also does is that it also ensures that you understand the intersection, obviously, of social determinants of health as well. So vaccination isn't just separate from some of these issues that play a role in one's health. Just to take it a step further, the Europeans have also looked at this, at healthy aging, and have also looked at it in the context of the social determinants of health, understanding what the barriers of health are in Europe, and also what life course vaccination will do in terms of the health of their communities. And this really paper really highlights that and puts that together with the social determinants of health and understand the barriers in which, in particular in Europe, about what would facilitate or impede life course vaccination and also healthy aging for their populations. So just in summary, when we talk about life course vaccination, I think this is a graphical example of what we're talking about. So you're looking at key vaccines that you want to have for your people in the various stages of life. And this is just an example of a list of vaccines that would be key. Obviously, depending on where you are, region, country, you may pick some of those. I think the discussion this morning you've heard from Morena is, of course, is vaccine availability, who's manufacturing at what cost, and obviously it's going to be issues about whether your government can afford particular vaccines. But again, this is just highlighting where some of these vaccines may play, in particular in relation to people's age. So what will it take then to implement life course vaccination? I think obviously policy is certainly one issue. You have to look at your health service infrastructure. Again, it's going to look at different stakeholders as well, understanding that, and then even if you start implementing, you need to understand what will you monitor, what will you measure, and the question is always going to be, what does a life course vaccine program look like? What would be good? What does bad look like? And all of these things are going to be part of what you should be able to do. And then, of course, the other issue is going to be about producing evidence of either the benefit of particular vaccines. When you look at health services, I think I think life course vaccination is probably also a cell in the sense that it's going to be also part of health system strengthening. But again, you need a good health system to be able to introduce that infrastructure. And then really the issue of equity comes through. And certainly it's going to be also about producing the evidence and evidence for practice, but also evidence for some of these antigens that you'll be using, and certainly the evidence for that in particular populations. For example, I think RSV in this country is certainly being recognized as a priority, certainly for the EPI, but also now also looking at maternal vaccination. But again, we still have an epidemiology gap in terms of understanding RSV in the elderly and what we're going to do about that in terms of if we're wanting to achieve healthy aging for that particular group of people, because that infection is still going to be an important infection to address in the elderly. I mean, there are no therapeutics for RSV, so a vaccine is probably the best bet would want to have for that particular group. Right, so this slide just probably summarizes some of the key actions that need to happen if you're going to embark or expand on life course. And I think there are going to be issues to happen at a number of stages or interfaces. We've talked about policy, but also healthcare workers are going to be key in terms of educating and understanding that vaccines are also important in beyond childhood. So the next slides are just going to be examples of countries which are embarking on that. So the first one is, I think, the Bangladesh example. They have adopted life course vaccination and are looking at implementing that. And they've taken a different route. So they've taken a particular stance in how they're going to unfold it, certainly looking at a gradual unfolding of life course vaccination. So targeting, for example, maternal vaccination is a particular step they've taken. Whereas if you look at India, India has decided that they're going to choose a number of vaccines which they will drive for their life course vaccination, and then also have highlighted where it will take place and who is going to be responsible for doing that action. So this is just some examples of how some countries are embarking on it in terms of how their policy is going to unfold in terms of life course vaccination. South Africa, I think when you compare us to other countries, certainly we've got guidance documents for adult vaccination. So you'll see influenza and pneumococcal vaccination are certainly there. But I think in terms of a well-structured program, I think we're still not there in terms of understanding who's going to do what for particular vaccines, where is it going to be, where are you going to get it, who's going to advocate for your vaccine. If we take influenza, for example, I think we get less than 1 million doses in the country. And if you look at high-risk groups, I think there are more than 1 million people who need the influenza vaccine. So if you take HIV, people living with HIV as a risk group, which is a high-risk group and need to be vaccinated for influenza annually, we're sitting at 8 million people. So certainly 1 million doses of influenza vaccine is just not going to be good enough. So again, it's important to understand that your program should be able to sustain the indication for which you want your vaccine to be for the people you've indicated it for. This is just to highlight that when we just look globally, I think respiratory infections are still at number 4 or topping the list in terms of leading causes of death. This is the 19, and many of those are vaccine preventable. So I think this is just to say that we can't necessarily ignore some of these respiratory infections because they're leading causes of death globally, and certainly that's the case in low and middle income countries. So this is me just creating a wish list. So if you were to ask me what would be life course vaccination in Africa, I think this, for me, it would look like this. I've taken in blue there, it's just highlighted the ones that I think are key. And you can see that I've structured it in terms of adolescents, adults, and then the elderly, and really chosen a bit of more of the respiratory infections, but also some other key vaccine preventable infections that I think we should be vaccinating against on this continent. So what would be the way forward? I think the way forward for the continent is really getting policy in shape, finance in shape as well to support vaccine programs for adults. I think need not only continental advocacy, but national advocacy to drive the agenda for life course vaccination. It's certainly part of the SDG 3s and all of that. So certainly can't ignore that. And then we've got to make sure that you get all the relevant sectors at the table, really crafting a program for countries. And again, countries then should propose what their priority list should be. And I've just given an example of what I think South Africa should be doing. This is just, I think, when we're looking at the world beyond now, certainly the issue of antimicrobial resistance is something that is something that we're grappling with. And just to remind you that vaccination certainly is a strategy in mitigating against antimicrobial resistant infections. And there are going to be some vaccines which are going to come to the fore for some of these very difficult to treat infections. Again, that has implications for vaccine programs in terms of identifying and how they would fit in vaccine programs, but just something for you to be aware of. So really, I think just to conclude is to say that I think vaccines certainly are key in promoting health equity. Certainly, there's economic value of the use of vaccines even beyond childhood, and really that vaccinating beyond childhood is a economic value add, and really need to have national programs that begin to embark on the path of life course vaccination. So really need to get sort of consensus from policymakers, civil society, and non-political organizations that we need to start upscaling on life course vaccination. And with that, I thank you very much. And those of you who want to come back to Cape Town, I just invite you to attend the upcoming conference in December. Thank you very much.
Thank you very much, Sipho, and for that. We've really had number of great speakers throughout this whole week, but a man who respects your tea is a rare man. Let's start with two questions online, and then I will ask these two to be the next here online or here face to face.
We have a question from Mohammed. He's asking how much should the health systems and services expand to accommodate adult vaccinations from what it is right now? And I think his follow-up question to that is how cost effective would this be when you compare to childhood vaccinations?
Okay, I'll answer the second question. So the data in terms of, if you look at a full course vaccination, any vaccine for adults, your return for value is about 19 times. So in dollar terms, the estimate is that the profit you'd get from that is about in the order of about $5,000 US. So there's certainly economic value when you look at an adult vaccination program. So if people complete their vaccine course, right? Now, I think that's probably a conservative estimate, given the fact that I've shown you or tried to explain to you that there are other benefits of vaccination. I mean, we haven't talked about the benefits when you look at AMR, for example. So it's probably a lot more to that. The first question is how much should countries expand on adult immunization programs? I'm going to be biased because I think that they should, and they should do everything. Now, you have to be pragmatic. They can't, it's all about the money available to do that, right? So I think the first thing is that, in Africa, lots of respiratory infections. We should be doing better with influenza vaccination, for example. Certainly, there are a number of adults with comorbidities that qualify for influenza vaccination that we're not doing. So I think that's a first start. Once we get that going and that infrastructure going, we can then talk about pertussis, pneumococcal vaccination, which are another key vaccines that adults need. So certainly, I think we're not doing as well. And I think the reason for that really is that you can't talk about a program if there's no policy framework. So if countries don't have a policy framework, then, then people just do whatever they want to do, right? So if there's no policy framework, there is no program. So I think countries need to have a policy framework that's clear, what the actions are, what the targets are, and what success looks like. And then we can talk about the extent of expansion and what antigens to add, et cetera, et cetera.
Okay, thank you. The second question is from Tambe. He's asking if the government funds this life course vaccination, and he's asking whether Western countries do fund life course vaccination.
Yeah, so globally, you're going to have different ways in which governments approach this. Many European countries, life course vaccination is supported by the countries, but it's not always the case. There are some countries where it's a mixed bag, and it's up to people to do that. And it just depends where you are in terms of how your healthcare system is arranged. So in South Africa, for example, you have a public sector and a private sector, right? So the healthcare funders for those in the private sector should be funding vaccination in adults as a health benefit, right? And if you're accessing public health, government should be funding that. So where I sit, I would advocate that certainly governments should be funding adult immunization, and where you've got this mixed bag of sort of government funding and the health insurance industry, they should be doing that. It shouldn't really come out of the pocket of individuals to fund their vaccination.
Question here.
Hi, thank you so much for your talk. I just want to understand with adult vaccination, because we know as you get older, like your slide said, non-communicable diseases become much more of a challenge. So how do you advocate for vaccination when there's a bigger problem happening the side, you know, like your strokes and your kidney disease? So how do you advocate for vaccination in that case?
Yeah, that's a good question. So the data is beginning to show that if you've got chronic kidney disease, for example, chronic respiratory disease, when you get your influenza, even if you survive that, you are more disabled after a hospitalization. I mean, you can take it even a step further. Your 10-year mortality risk, you know, increases. So in 5-10 years, just because of that hospitalization, you may not be alive, right? So what you're doing then is by vaccinating those people with those comorbidities, you are certainly going to avert some sort of mortality, you're going to avert some sort of disability. So you have to see it as key to keeping people healthy and productive. Remember, especially for adults, if they have a comorbidity and are healthy, they can work. I would argue that they often pay back for that vaccine they receive. Because if you keep them alive, the amount of economic generation you get, you know, the tax they contribute often just pays back that off, right? And I think that's one of the benefits of the vaccines. I'm not sure you can do that with any other health intervention, right? I'm not sure that the dialysis does that. I'm not sure that the diabetic medication does that to any degree. So I would argue that vaccines actually do a whole lot more as a health intervention than all these other things. These wonderful drugs that people talk about have been yet to outperform vaccines.
Thank you
Now,
very
that's
much.
my bias.
Thank you for your discussion. I'd like to ask, part of diseases that you mentioned that you showed us on the slide is stroke, breast cancer, prostate cancer, and other end-of-life diseases like that. Are there any vaccines being put in place or in the pipeline, let me say, to prevent things like diabetics and other things? Yes, we know that a number of them are other infectious diseases that are being looked into. Thank you.
So I think if I understand you correctly, you're asking about vaccines for cancer prevention. That's not my field, so I only can talk about infections. But look, theoretically, you're right. In the future, there could be vaccine developed to avert any of these malignancies that we have to deal with. Yeah.
There's a question that side.
Okay, thank you so much, and thank you for the wonderful presentation. I think I'm really enjoying this morning's presentations. There's a slide you showed about your wish list. I don't know if you remember, where you have a boy, then you have a man, and you have an elderly man. In the spirit of equity, either I'm missing something, like there's something I don't know about that slide, or because I couldn't help myself. Where are the women in terms of your wish list? I know it was your wish list, but I was like, where are the women? And I'm saying this, yes, I'm saying this because it starts with what you see also. Yeah, so as much as it's an illustration, where are the women?
Look, I think it's a fair point. I will accept that I'm a victim of patriarchy. So the non-display of women is not that I don't think women are important. I think they are, and yeah. So I think women do feature in that wish list. So all of those infections I've listed as a wish list affect women and men equally, right? So I will change my slides for my next presentation. Thanks for that.
Sipo,
Greg is just going to make a quick comment while I'm moving.
if I may just respond to the comment earlier about cancer vaccines.
Yeah.
There's a hell of a lot of work in that field. In fact, there are a few licensed vaccines, prostate cancer, one of the glioblastomas of the brain that are licensed for use already, and there are a number of others in the pipeline. So that's big business. Big business.
Yeah.
Yeah, my concern, there's a slide I would really wish that you could pull it, I can't get the number of the slide. It's a life course immunization, okay. I see a series of graph that talk about pregnancy, infant and children, adolescent, adults, elderly. My concern is, if we are able to address this particular issue from the era of pregnancy, why is it that the need for vaccine keep increasing along the way, especially to the elderly?
That's because one of the things is that not all infections happen at every stage of your life, right? So for example, if you take RSV, right? RSV affects infants, right? And currently, there are no vaccines that you can use in infants before, to protect them before they can get vaccinated. So one strategy is to do maternal vaccination, not necessarily to protect the mother, but to protect infants, right? Because you want to protect infants during the early neonatal period where they're highly vulnerable, right? Then you may see RSV doesn't appear for adults, but may only appear in the elderly, because that is when you're again at highly vulnerable for RSV. And you may need to be vaccinated at that point, because you may not have, even if you say you're a woman and you're vaccinated during your pregnancy, but the vaccine does not last until you're 65. So when you get to 65, you would need to be vaccinated again so that you've got good antibodies and therefore get protection. So yes, it may look like the list goes on, but it's just about where you are and how vulnerable you are. I mean, it can get complex because if you just add high-risk conditions, so diabetics are going to need particular vaccines. People living with HIV are going to need particular vaccines. But remember, the objective here is to protect individuals so that they can live a healthy life and contribute to society. So what you choose as a country is going to differ. Again, that's the main important issue, is understanding local epidemiology, understanding who's at risk, and then whether a vaccine program in your country makes sense for that either risk individual or the life course.
Thank you very much. As a program manager for service delivery, I have moved from the vertical program of child health, EPI, inclusive of school health and school health vaccinations, which is the HPV and TD, Tdap. But the complexity of vaccination is quite a challenge to align to a life course vaccination. Previously, you would find that with the vertical programs, maternal vaccination was there, and then elderly influenza is in another program. And those people might not be aware of the technical issues, the programmatic issues, the practical issues of aligning vaccination and supporting the actual administration into the arm and the cold chain management. I now find that, so in the Western Cape, we are aligning our vertical programs to life course programs, where early life course, late life course, and then with me now is life course vaccination. I do find it a major challenge that at national, the policies are still vertical and the vaccination provider sources are not aligned. So for the cervical cancer policy, the first objective is primary vaccination prevention. But now the national person responsible to procure the vaccines will tell you, no, we can't implement that because we don't have the vaccines. We don't have the cold chain capacity in all the provinces. And the same with the new TB guidelines. There's now new TB guidelines reflecting on childhood vaccination, catch up of BCG for adolescents. But again, it's not aligned with procurement and other things. So I also want to say, as countries move forward to life course vaccines, make sure you don't lose the skills. Don't make sure policy doesn't run away from the skills of administering at service level. Thank you.
Yeah, no, thanks for sharing that. Yeah, I think what you're trying to highlight is obviously people have to think creatively about how they unfold a life course vaccination program. I think we've lost an opportunity with COVID because I think I was hoping that would keep all those COVID stations and that just becomes a vaccination station for everyone. You come in, you know, there's already a digital record. You can, you know, you come in, oh, you need to top up your pertussis. Let's do that here because the issues of cold chain would have been sorted out in such a facility. Oh, you know, you need your measles vaccine. Let's give it to you.
Ben? It's
Thanks,
working.
Sipho.
You're not allowed to ask difficult questions.
You've touched on what I wanted to ask on, lessons learned from COVID in terms of building onto life course. And I'm wondering whether there are some practical lessons that you feel, like low-hanging fruits we can build on. For example, advocacy. With COVID, we know the public got to understand, vaccines are for everybody. And are we doing enough to build on that lessons learned?
Yeah, no, thanks, Ben, for that question. So I think we haven't done enough to learn the lessons. So I think one of the things about COVID was, the stations that we created just overnight, right? I was hoping that we would keep those facilities. The issue of a digital vaccine record, that infrastructure could have been built onto the EPI program. So all of a sudden, you have a digital record of all the vaccines. It becomes very easy then to do catch up. Becomes very easy to know who has not been vaccinated or not because there's some sort of record of that. And I think so. We've lost on that, and then I think we've probably also lost on making vaccination easy. Because if there are stations that are recognized as centers of vaccination, anyone walks in almost at any time and gets a vaccine and you're out within 5 minutes. I mean, currently the infrastructure is that if I need a vaccine, I need to go to a clinic. I have to wait for 2 hours if I'm lucky to get a folder. Once I got the folder, it's probably going to be another 2-hour wait before a healthcare worker can then address my vaccination, only to find that, oh, we've run out today.
Okay, thank you. I think I wanted to thank you and close, but I suppose I have an obligation to respect my elders.
No. I was going to ask you a related question in the context of why aren't we focusing on COVID vaccination now in Africa? Can you comment on that? We haven't discussed COVID at all in the last 4 or 5 days, but just your perspective.
Yeah, so I sit on the regional technical advisory for WHO on vaccines, and this question came up about whether we should make a recommendation for COVID vaccines for countries in Africa. So one of the things, of course, is that COVID rates have come down, but it's not zero, right? So the question is, if we're going to advise vaccines, where does it sit, right? I think on our continent, it probably is shifting from universal vaccination to probably key populations. So the key populations would be certainly people 60 years and above. I think that would make pragmatic sense in our continent. And then you add high-risk conditions. So you can add obesity, respiratory infections as others who need to get vaccinated. So that's the one. But just like every other country, South Africa, I can't get a COVID vaccine. There are none. And I've spoken to one particular manufacturer about when are we getting it, and it's still very quiet. So we can have a recommendation, but access is still an issue. So even in South Africa, there are people who need a COVID vaccine, but there is no vaccine, so access is the issue. So again, manufacturers need to come on board. We need the vaccine first, and then we can make noise about who needs the jab.
It's 25 million to BioVac to make the vaccine.
Yeah.
No, thank you very, very, very much, Sipo, and thanks for again coming another year here. So can we give him a round of applause? Thank you so much. I'm just gonna hand the mic to Edina to just make an announcement about our fashion photography.
Let me just. All right, so full confession, I made a mistake and I put the group photo session on Friday. So if you're not in your most fashionable state, I am sorry, but we will have to capture you as you are today. So we're going to move, we're going to move outside. There's no time to check your makeup. There's no time to check anything. We're going to move outside to take the group photo. And then we can then move on to tea and come back for the next talk. The next talk is online, so you have to be seated here. She will start. Thank you very much.
I am chairperson for this second morning session on the fourth day of the AABC. I hope you're all having a lovely time. We have a fun session ahead of us. We are discussing the central role vaccines are playing in protecting our underserved population and managing public health mass gatherings. First up, we have an online speaker, Dr. Opokuya Ofori Eninam from GSK, and she is speaking to us about the malaria vaccines and the SAGE recommendations and the way forward for Africa. Dr. Opokuya has been integral part of this development. Of the vaccine, malaria vaccine rollout, and I'm very excited to hear her share her knowledge on this very complicated vaccine. Okay, over to you. Thank you very much.
Hi, good morning. Can you hear me, please? Good morning. Good morning. Good morning. Can anybody hear me? Okay, thank you so much. So I'm sorry, I can't hear you. I'm really sorry, whoever is speaking, I can't hear you at all.
You can talk now. Can you hear us?
Yes, I can. Okay. So I'll just assume that everybody can hear and I'll start. Can you tell me if you can see my slides, please?
We cannot see your slides yet.
Okay, I'm going to try again.
They were there, but now they are gone.
Says you're screen sharing on my side. It says screen sharing. So can you confirm that you can see it, please?
Okay. We can see you.
Wonderful. Okay. So good morning, everybody. I'll just show my slides and then we can begin. So you can stop me at any time if you have any questions, and I'll be happy to talk you through it. So I was asked today.
Sorry, Opokwa. We still can't see your slides.
Oh dear.
Can you stop sharing and try sharing again?
Okay, I'm going to do that again. Okay. Share. Can somebody please tell me if they can see them?
So we can see your screen. So if you just go to your slides now.
Is that better? Can you see the
Awesome.
slides?
And now
Please?
present it.
Okay, wonderful. So I'm sorry for the little
Yes.
hiccup this morning, but good morning, everybody. And I was asked to talk today about the SAGE recommendation with the malaria vaccines and the way forward for Africa. I wanted to talk a little bit, just to introduce myself about GSK and our global health model, because I think that works into a little bit about why we work in malaria, why others may also work in malaria. Then I wanted to use the RTSS vaccine as a case study to illustrate challenges and solutions to deliver health impact in low resource settings. And I wanted to talk about the second malaria vaccine that has come out, which is really good news for the children, and a little bit touch on misinformations about RTSS and R21. And then just touch on challenges post-launch of a vaccine, and then go on to what next. So in a nutshell, this is what I will be talking about. So as I was introduced, my name is Opokwo Forenyinam. I work in GSK's Global Health Development team. And my work, or what we aim for in the Global Health Unit of GSK, is to change the trajectory of diseases with a focus on prevention of treatment of infectious diseases. We have a dedicated team which is outside of the main GSK business, and our approach is three-pronged. So we have a global health R&D unit, and they are the ones who are working on vaccines, drugs, monoclonal antibodies, etc. And then you have the access group, and that's where I work. And what we are doing is that we are trying to ensure equitable access to GSK's portfolio and pipeline. So I try to bring in the science, and I have other people who work with the advocacy. It's important to note that our global health team is non-promotional, so we're not allowed to promote, we don't promote our products. And then we have another unit, which is the Health System Strengthening Unit, and they work mainly with groups like AMREF, etc., to ensure that there's funding for all the things that go into bringing a vaccine or a product out. So we focus mainly on a couple of things, because as a global health unit, we are focusing, as I said, on infectious diseases. So we work with tuberculosis, we work in malaria, we work with AMR, we work in HIV, and then also we try to contribute to the elimination of things like NTDs and the control of viral threats, and essentially just expand the access to GSK products that are useful for people living in these countries. So then I'll just go on to my talk, and I'll start with, why do we need a malaria vaccine? I mean, yesterday when I was listening to the talk for Professor Ralph, and it was very interesting because people asked questions like, after all, we have this and we have treatment, we have other things, so why do you need a vaccine? And the reality is that with malaria vaccines, we do have things. We have the intermittent residual training, we have bed nets, we have some preventive therapies like SMC, so seasonal malaria chemo prevention. We do have also treatment, and then also, of course, we have the ACTs that are working quite well. However, none of these recommended malaria control interventions are sufficiently efficacious to serve as a standalone intervention. So It's important to know that a malaria vaccine is one of the high impact interventions that are currently available. And there is scientific evidence to show a reduction in clinical malaria, severe malaria, and deaths. So when you incorporate this into the mix of the prevention tools, you can contribute to maximizing the impact and having an impact on malaria. And again, for the malaria vaccines, WHO recommends that countries use whatever available local data that is. And then you try to combine to such that you have an optimum impact and save lives with what you have. So just to continue, I mean, what is the role of SAGE? And I mean, I was asked to talk about SAGE, but then also you have to take into account MPAG because they all work together. Now, SAGE is a strategic advisory group of experts on immunization. And then they work together with the Malaria Policy Advisory Group. And these people, they are advisory to WHO. Now, SAGE is mainly up to about 15 experts. So what they do is they review the product, they look at the evidence, and they provide evidence-based information and or guidance or strategy recommendations. They also provide technical advice and recommendations, and this is what happened for the duration of the malaria vaccine implementation program. I'll talk about that later. So again, it's important to know that these people are not biased. Their capacities are based on their science and their technical knowledge and experience. And then again, it's their commitment and willingness to volunteer the necessary time and effort. It's important to take this into account because the reality is that there is no bias, hopefully. I mean, again, these are individuals who are working independently. And again, the aim is to have the best product for the countries. So what did WHO do? What does it recommend after all the evaluations? WHO recommends the programmatic use of malaria vaccines for the prevention of P. falciparum malaria. It's important to note that we only have a P. falciparum malaria vaccine right now. And they prioritize areas of moderate and high transmissions. But then they have said that if countries want to give it in the low transmission settings, they can. But then the decision on expanding should be considered at country level and the basis of overall malaria control strategy. It also depends on affordability and cost effectiveness and the considerations whether the inclusion in such areas would simplify delivery. So I first thought that I would try to talk you through a slide which was made by one of my colleagues. So it is, she tried to put together a product development plan. So if you talk about the market access pathway, and this is because for diseases of the developing world and products for the disease of the developing world, they don't traditionally, at least now the way they're being developed, do not traditionally go to the high-income countries. So which means that throughout your delivery or throughout your product development and delivery, you have also always hurdles that you have to work into. So just to start, I will just try to get my pointer working. So, we start with discovery. So you have a product, you go into preclinical, you have early stage, late stage, then you register. So now we call this part the translation hurdle because that's where you have a do and die. And most programs have a sort of cutoff where they can say the product works or not. So we stop the product or not. And then you have the early stage, and you have the late stage and registration. And then here you always run the risk that your product will not go forward. And then after that, you have, here's where SAGE comes, you have them translating the science and the advice from SAGE and impact into national policy. So you have to look at the safety, quality, and efficacy of the data to see if the intervention has a favorable benefit risk profile. Then comes the biggest hurdle. How will you finance and buy the product? So currently, policy means that we have to look at a pooled procurement mechanism and to look for funding to ensure that there's continuous supply of products when they're made. And then the implementation, as I said, is based on stage recommendations or national global treatment guidelines. Now, why am I bringing this up? Because again, I'm trying to explain to you the risks that are associated with bringing a product like we have into the market. And the reality is that we can't do that alone. And we work with a lot of partners. And a lot of these partners not also taking into account that we also have the investigators, and they are the key ones, and the people who offer their children for us to be able to do their research. So why did we start looking at the RTSS vaccines? For us, what we wanted to do was develop a vaccine that would protect children. It had to be safe and well tolerated. Because we were bringing it into the EPI system, wanted to be sure that we could co-administer with standard EPI vaccines, and it had to be efficacious in different malaria transmission settings. Now, if you look at this, look at how long it took us to bring the malaria vaccine out. When I described a little bit what we did, you saw the whole project started in 1994. Again, as I said, in partnerships. So we worked with the Walter Reed, and then we had to develop the antigen. And then in 1997, we had a big proof of concept. Remember, I told you that at each stage of the development, there are times when you either stop the product or you move forward with it. And here we were able to show in a human challenge that you had up to 80% or more vaccine efficacy with our antigen. So then we started the trials in the Gambia, and that was really, as I said, in partnership with the MRC. And we chugged along, and in 2000, we started a partnership in 2001 with MVI, Malaria Vaccine Initiative at PATH. Now it's just called PATH. And at that time, it was because we were able to have a proof of concept. Remember, I explained to you at each stage, you have to look at it. So this is when we started our partnership with PATH. Then we started our phase 3 efficacy trial in 2019. And this was a staged, we had interim analysis looking to see if the product was working well or not. So from 2009, we got our final results in 2015. And we had been discussing all of this with WHO all throughout. And in 2015, we went via a route which meant that we went to the European Medicines Agency so they could give an opinion based on how they would treat any new product. And then based on that, if they gave a positive opinion, then we went to WHO to go and present the data that we had. So in 2016, we were able to present to WHO. However, this being the first malaria vaccine, there had also been, and there were also some potential safety signals, which, given the size of the study, we're not even sure whether this was real or not. So what WHO recommended was what they called a pilot introduction. So the pilot introduction was aimed at looking to see if the safety signal, this was the imbalance in meningitis, there was an imbalance in cerebral malaria, and then through a sub-analysis of another sub-analysis, there was a potential to see if the product worked much better in males than in females. So that was what happened. So that is why this pilot implementation was set up. And then again, the vaccine is a 4-dose vaccine. So then people were asking, is it possible to implement this vaccine? We already had our positive recommendation from going through SAGE, going through MPAG, the product was pre-qualified, etc., etc. So then we started a pilot implementation. Now, again, I want you to see how long it took from the time the recommendation was to when it started. This pilot implementation was being led by WHO and also with the Ministries of Health and other bodies like PATH in these 3 countries. So it took 3 years before they could start this. And meanwhile, we had the positive opinion in 2015. So then in 2021, we started at risk because the data had been coming in, the data was positive. So we started at risk collaboration with Bharat Biotech. The idea was that if we went to Bharat Biotech, eventually, given the cost of goods, the price would go down. And if there was sufficient volume requested, then the price also goes down at the same time. So the results of the phase 4 came out. And then again, after that, we had to go to find somebody who could help to pay for it. So the Gavi decision to support the malaria vaccine program was in 2021. So in 2021, we got a first recommendation. So WHO gave its recommendation. And we got the pre-qualification in 2022. And it was only in 2023 that we got an approval to start deploying the vaccine. And then in 2024, the first country outside of these 3 MVP countries actually started rolling out the vaccine. Again, if you look at this, 2015, it took almost 10 years before the vaccine was available for people who needed it. Again, RTS says we followed, as I said, an unusual regulatory pathway, as I had explained. So we went through a stringent authority, then WHO recommendation, pre-qualification, and then we went to the national regulatory for approval. Now, the problem really is that when you bring out a product that way, we ended up having a product which was expensive. Why? Because as the pioneers of this malaria development, we had to go through, we had the stops and the starts, and we had to be sure that the product would work and that would get return on investment. And when we went to the countries already in 2021, for them to tell us what would you need, how much volume, we didn't get that information. So what happened then was, as a result, we couldn't make a manufacturing plans and manufacturing was delayed. And again, what happens then also is that if you restart after stopping production, it takes up to about 5 years or more to get to full capacity. So which means then that at the time we're given the recommendation, we could only offer a limited amount of vaccines, which fortunately, thank God, we have ramped up and now availability of vaccine is not an issue anymore. What data was used by SAGE to give its product, or to give us a positive opinion? Or why did WHO actually agree to use this vaccine? The first data was based on what we call the phase 3 data. And it's important to know that this was an age-based vaccination, which meant that if children are at a certain age, they just came in and they got the vaccination, irrespective of whether it was at the malaria period or not, and or other things. So it was purely age-based. So this was done in several countries. And we looked at malaria transmission intensities. Why was this important? Because as you all know, we have low, medium, and high transmission areas. Now, if you're in a high transmission area, the force of infection can affect your results. Whereas if in your low-income countries, the force of the transmission on, if I may put it that way, on the vaccine efficacy is much less. So that's why we decided to do this. So we looked at about 16,000 children, and it's important to know that lots of these were co-administered with the routine vaccines, and those are quite a high level of bed net use, etc. It's also, there was no seasonal malaria chemo prevention available at the time we did this study. So what did we show using an age-based vaccine efficacy? So I'm just taking the product, focusing on the group to which the vaccine is available right now. So as I said, we had 3 primary doses, and then over the first 12 months, we had a vaccine efficacy of 51%. And then what we saw was that efficacy went down. So then we split this group into 3. So one group got a booster, and the other group, they did not get a booster, and then we still had the control vaccine. And what we saw was that you did need a booster to a certain extent to maintain vaccine efficacy. And if you did not give a 4th dose, although you maintained vaccine efficacy, over time, this went down much more. I remember what I was talking to you about, talking about the effect of transmission. So I'll explain this side. So this slide looked at the vaccine efficacies and the impact when you have in children in these studies. So for example, if you go to Kilifi, where if you look at this stage, this is talking about how much malaria transmission there is. You'll see that with Kilifi, where transmission was low, we had almost 80% vaccine efficacy. Whereas when you go to other places where the vaccine efficacy was more challenging, so I'm talking about this is over a period of 18 months, okay? So you will see that as it goes up, the vaccine efficacy goes down to a certain extent. However, over the 18 months, as I said, it was somewhere around this. So if you take this into account, taking that into account, you may say, well, so what does that mean? It means then that here you're looking at the cases averted. When you talk about cases averted, that is the potential use of the vaccine. And you can see that even though the vaccine efficacy is quite high, what you do is that because there are so few cases, you actually prevent fewer cases. Whereas with places like Kintampona and Orosiaya, which have very high vaccine efficacies, if you give a vaccine, even if it has a 40% vaccine efficacy in that particular setting, the impact because of the number of cases that you prevent is much higher. The second piece of evidence that we had was based on seasonal malaria chemoprevention. So what it was that in certain countries in Africa, as you all know, malaria is seasonal. And here we're talking about places like Burkina Faso, like Mali, etc. And here in partnership with the London School of Hygiene and Tropical Medicine. So this work was done in Mali and Burkina Faso. So in Mali, it was done with Professor Alassane Dicko and his team. And in Burkina Faso, it was done with Professor John Bosco and Ouadrego and his team also. So the questions that we asked ourselves was, given that malaria vaccine has the highest vaccine efficacy, very high vaccine efficacy over the first 6 months, which tapers off, why don't we give the vaccine prior to the rainy season and then to see what happens? So again, using the concept of seasonal malaria chemoprevention. And you know that seasonal malaria chemoprevention, the drugs that you have between 60 to 80% vaccine efficacy each month, but it goes down very fast. So which means if you have the malaria period of about 4 months, you do need these boosts each time, these additional malaria drugs to be ensured that the children are protected. So we started the study in 2017. So we had an initial phase and then we had an extension. So one group just received the normal SMC. The other group received SMC with a placebo. And then the third group received the malaria vaccine. Okay, so this study continued until 2021. In 2022, as I said, 2021, around the time that we were having the discussions with SAGE and MPAC, we also had the results. So what it showed was that when you give RTSS and you give SMC, in the same period, the results we saw in terms of effect on clinical malaria and or severe aspects of clinical malaria, they were non-inferior to each other, which meant that the results of RTSS or SMC, at least analyzed as it was, did not appear to be different from that of SMC. But the best thing that happened was that if you gave RTSS at the same time as SMC, it was significantly better than other interventions. So which meant that what you saw was that you increased the vaccine efficacy versus just SMC alone for severe malaria by 70%. Blood transfusion, you had an impact on malaria death, and even after 5 years, which meant that you had your boost, you still had a significant effect, okay? So there was vaccine, there was an estimation by the group in the London School. And one of the colleagues there tried to estimate the vaccine efficacy with SMC over 6 months. And what you see is that after the primary efficacy, we had something like 76% vaccine efficacy. Now, bear this in mind because it is important, because when I get to the part where you have misinformation, you have to remember these numbers. The last point that allowed us to have, allowed for this positive recommendation in 2023 was what I call the Malaria Vaccine Implementation Program. And we are very grateful to the World Health Organization, as well as all the ministries of health in Ghana, Kenya, and Malawi for making this possible. So within that period, at least over 6 million children had vaccine doses administered, and there were at least 2 million children who received this at least one dose of vaccine. What was important to show was that there was no increased risk of the safety signals that we had seen previously. So this imbalance in the sort of risk associated with meningitis and an imbalance in death and or with gender. And the important thing is that there were no safety signals, so which meant that once you went into the population, you did not see an additional risk. But the most important thing, and especially for healthcare professionals, if you vaccinate 100 people, you have a potential to reduce mortality by 13 children. And that is very high, not to account for the fact that you do have an impact on severe malaria and hospitalization. And then the most important thing, because that was one of the questions that we had, was that, is it feasible to introduce in a system where you have other malaria interventions? And there the proxy that was used was bed nets use. And what they saw was that even though you gave the vaccine, there did not appear to be a decline in bed net use. There was a reduction in the numbers who got the 4th dose, but countries have developed a strategy, which means that before we went, because we had a positive opinion using a 0-1-2 vaccination schedule with the 4th dose given at 20 months, the countries adapted it such that they gave their 4th dose at the same time as the measles vaccination. And what they saw was that the increase was much higher. So again, if you remember what I told you about WHO, they said countries have to figure it out themselves. You know, you have 3 in the first year of life, and then you have at least one booster at the 2nd year of life. And then there were 2. So in 2023, the Oxford vaccine, the R21 malaria vaccine, also received a recommendation from the WHO. So this was important because it meant then that there were 2 malaria vaccines. Now, one of the things with the R21 vaccine, as I tried to explain, GSK, we had the RTSS vaccine, that was sort of the trailblazer, showing what you could do, what you couldn't do, and then introducing people to the concepts of a malaria vaccine. And that's very important because what it did, and what we also did, was we shared all the information, and that's important in research. You have to share your research so that people can learn from that. So the R21 vaccine is essentially, it's essentially like RTSS, except that it doesn't have free hepatitis B. And what their rationale was that they assumed that if you reduce the amount of hepatitis B, you had a more specific impact on CS, and as such, potentially a much better response in terms of vaccine efficacy. However, when they received a positive opinion from after looking at SAGE and impact, what happens is that they had a very small sample size. I mean, I don't think they had more than about, in total, in their development plan, I think about 3,000 maximum or something like that. So what happens when you have a small sample size prior is that then once you receive your opinion, you have a larger, what they call post-licensure commitments that you have to do. So I remember when this was going on, I was reading, and the SAGE recommendation was that we will license R21 because it is considered to be comparable to RTSS. So again, that's what I was talking about, that there's always going to be a first one. It took us 35 years, and I don't think it took R21 it took them less than 10 years to be able to do, because there was a concept, the RTSS vaccine. We had shared information, so therefore they knew what the pitfalls are. There was a positive opinion. There had been a recommendation, so therefore, piggybacking on that, you would be able to get the scientific discussion going much faster instead of being conservative, because there is one product that's already available. So again, as I said, they are going to be able to do, they have to do some cohort studies, which they are doing. They have to look at febrile seizures, because like our vaccine also, what you show was that there was the first week of vaccination, you did have a high malaria, high temperatures. So they have to look at that also. They have to look at vaccine effectiveness. Unfortunately for us, because as I said, it was conservative approach, we had to get license only after the MVIP. And then they are going to have to monitor for other aspects such as rebound and severe malaria. And then, of course, they have to look at severe malaria because the sample size was so small, so there's no evidence. And currently, there's no real evidence that the R21 vaccine has a massive impact on malaria and or mortality, because these you need a relatively large sample size. So I think there are studies ongoing, and hopefully we will get some results in the near future. Now, unfortunately, what we have to deal with is misinformation. So there is a lot of misinformation going around about RTSS and R21. Fortunately, when the pre-read or the pre-publication came out and talked about 70%, what it did was that it compared the data to that which you saw when you did an age-based vaccination. Whereas when the study was actually done under seasonal malaria chemoprevention stage, so which meant that it was done under seasonal settings. So again, you cannot compare the two. And it's very important because a lot of assumptions, and it's not, I'm only using malaria RTSS as a proxy, but you'll find this all the time also. There was misinformation in the sense that, as I said, in a seasonal setting, you have a big peak during the malaria season, and then it tapers off. So which means then that if you have a vaccine efficacy over this period where you have the hump, as the cases do not come out, your vaccine efficacy can be considered as maintained. Because if you look at the curve, you have a vaccine efficacy which stays. And it only means that you do not have more cases in your placebo. However, and then also, so this led, because there was so much misinformation, there was so much miscommunication, that WHO actually did an analysis. They tried as best as they could to try to see if if they could show if the vaccines were truly real, because this data was presented, and this was at the time that they were doing the SAGE meeting, and that's why they had said, despite not having data on severe malaria, despite not having cohorts data, etc., they would still do it. So what they saw was that this is from the SAGE. So if you go, there's a yellow book, you can find it, there's the evidence one, that when you looked at this group, so their vaccine was done in 5 to 36 months children. But, you know, the vaccine efficacy was around 75%. And then after 20 months, you had 73%. Okay. So what WHO tried to do is that using the data that they had, they tried to look again to see what the vaccine efficacy was. And so they said that of the first 12 months with the RTSS, you also got in the 70s, and 73 months again, it was maintained up to 18 months because that was the time they did analysis. Again, remember what I told you, you have a vaccine efficacy, it stays stable because there are no cases, you give another one, etc., etc. So again, these results did show that if you gave RTSS in the same conditions as this was done, there was a chance that they would be comparable. So again, as I told you, I talked about manufacturing challenges again, that, you know, we had to have the stop, start. Will we go through? Will we not go through? Will the vaccine be done? So we had initial manufacturing capacity, okay? So then we're waiting for the pilot recommendation. Will it be positive? Will it not be positive? So during this period, there was no vaccine that was created, okay? We had to stop production because we didn't know if it was positive or not. So then you have this period where nothing was happening. Then we had to restart again for the pilot supply. And then again, we started antigen stockpiling. So then again, it is important because there's a limited lifetime for a manufacturing facility. So which meant also that you had to change your manufacturing capacity to take into account the higher capacity that you would require. So again, manufacturing is one of the things you have to think about. And then, so that's why when we started getting the initial, we went, as I said, at risk to Bharat. And so we got the market authorization here. And now what we can say is that Bharat Biotech, in the process of trying to get pre-qualification, and what will happen is that their vaccine, there will be enough vaccine to come for what we need. So again, it's important because you are all people who in the ministries of health and are important people. Because again, for people to make a good manufacturing investment, it should be based on reliable forecast. So if your countries do not give a reliable forecast, then it means that this stockpiling for when the vaccine implementation is ready may or may not be sufficient. And also, the life cycle, it takes, the malaria vaccine is 3 years, and for example, the R21 is 2 years. So which means that if we stockpile and you don't use, then it means then that we will lose a lot of vaccines. So which means then that's why when Gavi makes out the call, you have to look at your situation and you have to decide if you would want that. So again, we're lucky because we could work with different people like MedAccess who try to help to bridge this period to keep our vaccine going. And again, that's what I'm trying to explain also, that you do have this period, we had this period of uncertainty. But R21 fortunately learned from what we had done. So they went through, again, the EMA process is long, it takes a lot of time. They learned, they went and they had their product made in India through SSI. And what they did was also, again, because with us it took so long to give access to children who needed it, they also decided to get approval via the Indian system, which is much faster than with the EMA, and then thereafter they went for the WHO pre-qualification. So again, these are all lessons learned that we can all take from there. The other big problem is, of course, with pharmacovigilance, because again, there's been a lot of publications out about pharmacovigilance and what the lessons that we learned. And then also yesterday I had someone talking about the fact that, I think it was a prof also talking about the fact that the different countries are also publishing some of the challenges and some of the solutions that they found for this once they started the vaccination of the children. So again, one of the PV challenges is that to a certain extent, the vaccine introduction it's been short, and the preparedness and the training is also sometimes could also be, for some places, was very short. So since it's an updated EPI schedule in the beginning, people were not sure where to put the fourth dose. Should we just do it 20 months? Should we do it 12 years? But then again, fortunately, WHO has given you the flexibility, because the important thing is to access and for people to have as much as possible. So some people give it at 18 months, some give it at different times, but the important thing is that whatever works for your country, you do that. And I think the recommendation from malaria vaccines is exactly the same for R21 as with RTSS. And then again, some people are going to choose to go through the seasonal method, because for their countries, that's what works best. Then we had this non-functional PV system in these new adopter countries. So then what happens is that it leads to underreporting or poor quality of the AEFI, so adverse events post-immunization. And then what it leads then is that you have coincidental events, you have rumors impacting the API system. Because what happens is that if there is a signal and it is not followed up, and it is not checked based on other existing data, then people can make rumors, oh, he got the vaccine and he got a headache, so therefore the vaccine is not good. And then also, we had, you can see that you had anti-malaria treatments, counterfeit and herbal medicines. All these things are all adding to this rumor mill. So what we have been advocating, and I'm sure it will be the case also for R21, because I'm just using RTSS as a case, is that communication and exchange of information in the countries is important, because the problem is that if people don't report into their AEFIs into the system, they do not, doesn't go into the bigger system, and country, and then WHO, whoever it is, cannot evaluate if any signal they see is real or not. And then also, I think what we've been advocating, I think is very important, because a market authorization holder such as us has the big database, So it would be interesting if, at least for the first 4 or 5 years, when there's a bigger rollout, that the data is shared with the market authorization.
Excuse me,
holder.
Dr. Opokua. You've
Yes.
got 2 minutes left.
No problem, I'm finished. So I think I'll just end up by saying that right now the vaccines are available in these countries, and there's a new wave that is expected. But I just want to end by saying that, I mean, a vaccine that sits on the shelf is really useless. And again, Gavi, they said, we have 2 safe and effective vaccines. There's greater supply security if there are 2. It means then that we can meet the country's needs. And what matters most is that the vaccines are impactful and can save lives. So don't listen to rumors. Don't listen to misinformation. There are 2 good vaccines that are out there, and we must act now to be sure it's available and widely implemented. Thank you. So I'm open for any questions.
Thank you very much. We're going to take one question from each side and a question from online. Over here.
Thank you very much for the nice presentation. I have just a few questions.
One.
Okay. Okay, just one. Okay, I leave the other. Maybe I had 3 questions, but let me take only one. The one I'm thinking is, according to slides, WHO had recommended that the countries with endemic of falciparum malaria to implement or add maybe for the routine immunization. Does that mean the vaccine only contains to falciparum malaria and not included the other types of malaria? Thank you.
Yes. It is not a Vivax vaccine, and the data is related to Plasmodium falciparum.
Okay, one more question from the floor.
I'm sorry I took
Thank
up
you
so
very
much
much for
time.
the
It would have been
presentation.
interesting to discuss.
Yes, you mentioned the coverages. Sierra Leone introduced the malaria vaccine in April, and yes, it's been complicating because the expectations was that the first dose, when we introduced the malaria vaccine, it was quite exciting from parents. But then as we move further with 4 doses, it's becoming maybe sweet bitter. Coverages are getting low, dropout rates increases. I wanted to know, are there plans to shorten visits by mothers to the clinic? Is GSK planning to recommend the production of single dose or 2-dose malaria vaccine?
Well, thank you for the question. And as I said, we are invested in doing malaria, so we do have a 2nd generation program that's ongoing. Currently, I think instead of focusing on that, what you have is a vaccine, but WHO has given you the flexibility to use it such that it matches your system. And again, from the data we have generated, R21 has not generated it that, but again, I don't think it should be any different also, is that even if they don't get a fourth dose, there is still substantial protection. So I think that's what is important. That's the message you have to give. So it's not because you can't give the fourth dose. You have to try as much as possible to ensure that children are protected.
Thank you very much.
We have a question from Abdul. He's saying, given the similarities in efficacy and the recent WHO pre-qualification of both R21 and RTSS, what are the main considerations or challenges that countries may face in choosing one vaccine over the other, especially regarding
Programmatic use. I think you have
vaccine
your
supply
people
and
there.
affordability? And
Yeah.
also, do we anticipate any regional or context-specific preferences emerging as countries evaluate these options?
As I said before, I mean, WHO fortunately has given, I mean, we provide the scientific evidence. SAGE and IMPACT assesses the scientific evidence and WHO makes a recommendation. So WHO recommendation is you give the first 3 in the first year of life, and the fourth, you have the flexibility to use it within whatever system that you have. In terms of affordability for the first couple of years, and we're very grateful for that, Gavi is buying the vaccine. So currently all the vaccines are at the same price. I mean, they're given to the country. So it's not because our vaccine is now expensive and that it will, it's that to the countries, the prices are the same. And then over time also, as I said, the cost of the vaccine, as there are more requests for the vaccine, you can make more doses, and then that also brings the price down. So that was the second one. So fortunately, Gavi has done that. The issue will be that once the Gavi funding, so the non-Gavi countries, they have to a certain extent, pay for it themselves. And that's where the issue about cost may come in. But fortunately, the cost of RTSS is definitely going to go down. And so eventually, I'm sure you'll have 2 vaccines about around the same price, and then it would be affordable to everybody.
Okay, we have a second question from Lori. She's saying, generally, before administering the vaccine, we make sure that the individual is not infected. Would it be possible to find a malaria-free subject in an endemic zone, or is there threshold parasite load for administering the anti-malaria vaccine?
The good news is that the recommendation doesn't say that if people have malaria, they shouldn't get the vaccine. What it says is that, I mean, and it's the same for every vaccine. If people have fever, you defer until the fever goes down. We have done, all our studies have been done for the children, have been done in malaria endemic settings. Some have malaria, some don't have malaria. We have data and evidence. And again, the data is a little bit and some people say that if they have had malaria before, you expect a better vaccine efficacy. And then some data also shows that if they've had malaria cases already, the vaccine efficacy goes down. But then again, it's neither here nor there. But the important thing is that if they have malaria prior to vaccination, go ahead. If they have fever, stop it as the same as every vaccine until the fever has gone down, and then you give your vaccine. So I hope with this flexibility, we will continue to use the malaria vaccine.
Thank you very much. We're going to take 3 more questions from the floor, and then we're just going to ask you to stay online and answer the online questions that way. Okay.
Thank you very much. I'm just concerned about the fact that the malaria vaccine is 4 doses. So I would like to ask, what's the maximum number of doses that an individual will get to have the adequate immunity? I don't know if there are studies that have been on that, because I'm looking at 4 doses and I'm looking at compliance and coming back to the facilities to meet up with the expected for. Thank you.
So again, thank you for that question. It's quite important. Important thing is that you give your 3 and your 4th dose. However, we have given up to 7 injections because under seasonal settings, as I explained, you have your primary and the year after you give boost. And in Mali and Burkina Faso, we've done that to a substantial amount of children. And what you see is that there are no safety issues. So again, I would say that, I mean, follow the WHO recommendation. The WHO recommendation is flexible, and you have to look at your setting and then you have to adapt accordingly.
Thank you. Another question?
Thanks so much for a very excellent presentation. I'm very passionate about the topic. I had the opportunity to work on the demand forecasting for malaria vaccine on the early phases of the launch of the program, when there was supply considerations and the allocation framework was being applied before the R21 came to market. There was a discussion around the hybrid strategy at some point also to be considered by countries. I kind of transitioned away from my past role, so I lost a bit track of how is the hybrid deliveries schedule is being considered. Other countries opting for that. And then my second question is, what is being done in terms of integration with other malaria interventions like seasonal malaria chemoprophylaxis, the bed net distribution, and are we starting to see results in terms of those kind of integrated activities in some of the countries that have already launched the vaccine? Thanks.
Thank you for the question. In terms of, there are some very good papers that are going to come up by the London School, and you have to look out for the papers from Jane Grant. So if you use Brian Greenwood, you should be able to find a lot of these papers. There are different modules that people have proposed. So you can do an age-based, you can do a seasonal-based, and then the hybrid model she's talking about is that you give your vaccination on an age-based, and then you give the injections prior to each season. So that means that you combine these two systems, and then thereafter you will be able to, so you protect them early, and then at the next year you give, and until the children are 5, as with other malaria intervention things. And that's what this study, which Chandra Mohan and also Diko et al. Showed, was that it is all still possible. So this model, I think, fortunately, WHO is open to discussion, and Gavi also, because they are the ones buying the vaccine and making it accessible. And I think there's some discussion about that also. And then in terms of other malaria interventions, as I explained to you, during the MVIP, that's one of the key things they talked about. The vaccine is not a standalone product. It is to be used in combination with existing mechanisms. So you do not take away your bed nets. You do not, if your country is doing IRS, the country has to make the decision whether they'll continue with IRS or not. But that's based on the countries. And then, as you all know, the malaria programs, they have different interventions, especially if you go to a place like Kenya. If you are low transmission, the intervention that is proposed may be different if you go to places where the transmission is medium and high. And I think the idea is that the malaria vaccine is an additional resource, because as you all know, the parasite is wily. I mean, as soon as you give it something, it changes. As soon as you give it a product, they become indifferent to it. So it's another part in this paraphernalia. It's just like they are trying to also make new drugs which you can put on the bed nets, to improve the bed nets, etc. So this is an integrated malaria approach.
Yes, so much. We have one more question.
Thank you so much for your presentation. Maybe I didn't listen, but what is the temperature conservation for the malaria vaccine? We don't know about that. And my second question, it addressed to all the presenters that talk about vaccine. Everything that was presented, it's very clean. We didn't heard about any adverse event that occur during the vaccine manufacturing progress, or for malaria specifically during the pilot implementation. Did you come across any adverse event related to the malaria vaccine? Thank you so much.
Thank you for the question. And right at the beginning, when I had talked, I mean, you do expect. I mean, again, as with most vaccines, there are adverse events that occur following malaria vaccination. For RTSS and also for R21, the most common is fever. Now, again, I can explain that in the sense that what you're doing when you have, because it's an antigen with an adjuvant, you're revving up the immune system of the child. And one of the side effects is that you do have sometimes fever, and in some cases it becomes high fever and may or may not respond, develop into something else. So it's not any different from any vaccine that is currently available. So that's the first thing I wanted to say. The second thing was that what I had explained when I was talking about the malaria vaccine implementation program was that during that there were three specific adverse events that were being looked at. So we call these adverse events of specific interest. The rationale for this is that when we did the phase 3 studies, there appeared to be some imbalances, but the sample size was too small because even with 16,000 children, you could not be sure about a causal effect. And that's why we went into the what we call an effectiveness trial. So what we looked specifically was an imbalance in meningitis, and that was not proven. So it did not occur. They looked again, as I said, there was an imbalance in cerebral malaria cases, and that was not available. That was not, even at the time of the phase 3, there was no real rationale for why these would be caused by the vaccine. So this was not available. And then they looked at mortality in terms of male and female, and that also, it was shown not to be there. So then when SAGE and MPAC look at data, they look at it in terms of safety, efficacy, and potential immunogenicity, because the safety is that, is it any better than any vaccine that's currently? Are the risks as opposed to vaccines on the market? Is it imbalanced? And so that's why I just focused on the key messages. But yes, I can assure you that SAGE and MPAC looked at all the data. The data we have currently is not any different from that which you'd see with most vaccines. And it's a little bit the same, because if you looked at R21, there was also a little bit imbalance in deaths. But then again, they were not they did not appear to be a causal effect. So I'm sure that once they go into something like, once they go into the effectiveness trial, or they vaccinate more, they will be able to better assess if this is linked to vaccines also, So that is what it is about. So again, as I said, because we were the start, we had to answer all these questions before other people came in. So in terms of it's kept in the fridge, so it's the same temperature as other vaccines. So that doesn't change very much. And I think it's the same for R21. Thank you.
Thank you so much. We are now going to go with the next speaker, but please stay online and answer the online questions because they are dying to be heard as well. Let me head up to the podium. We know how desperately Africa needs an efficient, effective malaria vaccine, and that was such a valuable talk. Thank you for everybody's input and questionings. We're working through all the things together, and that is why we're here. Next, we have Dr. Salim Parker, and he is speaking to us from the South African Society of Travel Medicine and considering vaccination during mass gatherings, which is an important topic for all our countries, which have people moving from one place to place. Come through.
Thank you for that introduction. You had the main act yesterday with Albie de Vrij, so I'll be doing the filler today as far as travel medicine is concerned. I've been asked to talk about considerations for vaccination during mass gatherings, and we have to bear in mind that people move. This is in daily travel that you see, the daily movement of people across between countries and across continents as well. And this slide is quite pertinent because it is estimated that by 2035, 11 billion people will be taking to the skies annually, if the world truly becomes a global village. However, since Trump has just basically won the elections in the United States and there's more protectionism in place, there will still be about 6 billion people taking to the skies on an annual basis. And before COVID, everything is pre and post-COVID as far as infectious diseases are concerned. But before COVID, about 4.5 billion people used to take to the skies annually, with about 1.5 billion. And on any day, there's about 10 million people not having their feet planted firmly on the earth. So if we look at travelers briefly, traveler can take a pathogen from his origin to a destination. He can disseminate the pathogen there. He can give it to fellow travelers, or he or she can pick up a pathogen in the destination area and then take it back to their country of origin. And like I've mentioned previously, life is before COVID and after COVID. During COVID, international travel dropped from 1.5 billion to, the total travel dropped from 4.5 billion to about 1.8 billion, dropped by more than 50%, but it is increasing quite rapidly now to pre-COVID levels. And we have to bear in mind that people just don't take to the skies. There are other means of transport as well. So let's talk about mass gatherings now. And the WHO definition of it is an event attended by a sufficient number of people to strain the planning and response resources of the host city or country. And since we're talking about infectious diseases, a super spreading event is one where an infectious disease spreads much more than is normally anticipated. So when we talk of mass gatherings, you get basically two types. The one is an annual one, which is which can basically say a planned one. For example, the Hajj takes place every year in Saudi Arabia at a specific time, at a specific place, involving specific rituals. Then you have the spontaneous type of mass gatherings, and the classic one was after Spain won the Soccer World Cup in South Africa, but there was spontaneous eruption of celebrations in Spain. People took to the streets, and 2 people died during these spontaneous mass gatherings. More than 100 were injured that were documented. So I'm just going to mention a couple of the larger ones first. And these are mostly religious mass gatherings, but I'll refer to the sporting ones as well. Now, the Kumbh Mela of 2013 had 150 million people gathering over a period of 55 days in India, all taking a dip in the river Ganges. Some of the studies says 100 million, but more of the authoritative ones says it about 150 million people were gathered. The Arba'in in Iraq takes place annually as well, and this 21 million people attended it in 2022, this 2 years ago. South Africa even has a large religious mass gathering. The Zion Christian Church has an Easter congregation in Moria, which is the northern part of our country, where over 10 million people attended according to the church. Then there are other ones, such as the Grand Magal in Senegal, which is attended by up to 5 million people annually over a weekend. The Bijwa Easter Mass in Bangladesh, again, 3 to 5 million people. Now, and there's other religious mass gatherings. Most of these large ones are attended by locals with a handful of foreigners. This is in sharp contrast with the Hajj, which I've talked quite a lot about, which is attended mostly by foreigners, with only about 20% of locals attending. The reason why there's a lot of emphasis on the Hajj is that there's a lot of literature on it, unlike the other mass gatherings. I'm sure Albie spoke about the pillars of travel medicine, and you'll see vaccination is a paramount part of it. When it comes to pediatrics, I include all adults in there as well, because as soon as people put on their holiday hat, they tend to become infantile in their thinking sometimes. And so that's why we always talk of safety as well. So basically, when we talk of the principles of travel medicine, we're talking of this person undertaking this trip during this time to this specific destination. And when it comes to mass gatherings, it's the same principles, but we also have to look at it in the context of the public and global health, as well as global securities. So what are the risks of mass gatherings? So there's traumas and stampedes, for example. Accidents, quite common. Infectious diseases is obviously going to be the focus of my talk. And then there's going to be other factors such as over 1,300 people who died during the Hajj due to heat exposure this year. But we also have to remember that there are benefits, which is not, we're not really going to touch upon. Some people consider it to be the opium of the masses. When it comes to infectious diseases during travel, this is besides mass gatherings, it appears that about only 5% of them are vaccine preventable. But of course, they are vaccine preventable. If you look at the numbers there, of every 100,000 people who travel, about 50% of them will require some medical attention, and 5% will have a condition which could have been vaccine preventable. But as a traveler, we are always, the doctors or the nurses that they see to consult about vaccines is always considered to be a necessary and a expense that they really don't want to undertake, and because it costs money at times. But we obviously should try to use our persuasive powers to encourage them to take the vaccinations. As you can clearly see here, that is the role of our group of professionals here. So when it comes to vaccine preventable diseases during travel, again, it's pre-COVID, and you can see here influenza used to be the most vaccine preventable disease in travel from a first world country to a third world country. And then there were other diseases such as typhoid, hepatitis A, and so forth. But post-COVID, the pattern has clearly changed. This was a study done last year which showed that COVID is probably the most vaccine preventable one, followed by influenza. And lately, and this is due to climate change and social upheaval, dengue has become much, much more prominent than previously. But when we look at vaccine preventable diseases, we don't only look at the incidence of it, we also look at the impact. Getting meningococcal disease in a far-flung country, which we know can kill within 24 hours, has a much bigger impact than a disease such as influenza, for example. So often, since post-COVID, we are literally building planes as we are flying because the information is not always there to give a categorical answer about what vaccines you should take or not take. I'm sure Albie spoke about this yesterday, so I'm not going to mention the mandatory and recommended and routine vaccines. But I want to really start concentrating on the mass gatherings. And there's been documentation of it for centuries already. But the classic one as to how they actually affect each other occurred in 1817 when there was an outbreak of cholera at the Kumela, which I'll explain a bit later about. There was an outbreak of cholera there. Returning pilgrims then spread throughout Asia. And this same strain actually later found its way into Europe as well. This was 1817. But by 1821, pilgrims to Saudi Arabia, now remember the Kumelas in India, this is now in Saudi Arabia. The same strain is thought to have been carried to the Hajj in 1821, where more than 20,000 people succumbed to the disease. Let's fast forward to more than a century. In 2017, we had an outbreak of cholera because of the uncertainty of war there. There was an outbreak of cholera in Yemen. And we know that 20,000 Yemenis undertake the Hajj every year in Saudi Arabia. Other factors that we also know of is that 80% of those infected with cholera are actually asymptomatic, but they are contagious. So they could have potentially carried it to the Hajj, disseminated the pathogen there, and then returning pilgrims could have taken it to the countries of origin and actually started outbreaks there as well. And even though there wasn't a readily available vaccine available during that time, the thought came up that it should have been given, but it wasn't enforced and we had no issues afterwards. I want to concentrate on my friend now, who happens with influenza virus. Now, we know that pathogens don't fly. It's we humans that actually give them wings, amongst others. I mean, we know there's a big avian reservoir of it as well. So let's go to 2009, the H1N1. We all know it as swine flu, the pandemic. There was a mass gathering, a Easter mass gathering in Mexico City, and we all know that the pandemic started there. It was called the Iztapalapa Passion Play, which was attended by about 2 million people. And the returning pilgrims, even though it was a locally, mostly a local mass gathering, it's considered that these returning pilgrims actually started spreading the pandemic worldwide. Like I said, I love this pathogen. We know that it undergoes antigenic drift, antigenic shift, and 2009 there was a major antigenic shift. We also know that it easily can undergo, exchange the genetic materials and actually create, in effect, new antigenic strains. So now let's look at where the flights out of Mexico flew from during the pandemic phases. And you'll see that most of the flights originating from Mexico City goes to North America and Europe. Of course, they can afford to go on holiday there. We can't. So let's see where the virus spread to. We know it started in Mexico City, but you'll see as the days goes along, first number of cases were in North America, South America, Europe. The Japanese love to go there as well as the Australians, clearly following the paths of travel, again showing the interaction between travel and the spread of infectious diseases. Now, I want to ask people now, if Trump was in charge of Mexico and he said 40% of people cannot fly out of the country anymore, by what rate would we have been able to decrease the spread of H1N1 pandemic in 2009 if we had to decrease travel by 40% out of Mexico City? Anyone wants to hazard a guess? Quiet people, you know, only 2 days. Now we're really becoming Trump-like. I love this guy. We're now going to prevent 90% of people leaving Mexico City. By what rate would we have decreased the rate of the spread of H1N1 pandemic by? 2 weeks. So if these guys want to fly, they really move. But again, we can't only look at one pathogen in isolation. We know, for example, that the Spanish flu of 1918, where there were more than 50 million deaths documented, most of these deaths were actually secondary deaths due to pneumococcal infections, and the review of autopsies have confirmed this. And the pathology is considered to be the following. This is the respiratory epithelium. Influenza virus basically denudes the respiratory epithelium. It upregulates receptors to which pneumococcus can attach. And then you have the invasion of pneumococcal bacteria causing pneumonia or sepsis. So now I want to introduce you to the Hajj. And this is the densities of people that you see there during the more populous times. So on an annual basis, you have about 3 to 5 million people attending the Hajj. The pilgrim density is up to 9 people per square meter. And the respiratory illnesses has been documented in certain studies in up to 90% of those attending. And they make provisions for this. They have over 20,000 medics attending purely to the Hajj pilgrims. And as far as the Hajj respiratory diseases are concerned, it's a leading cause of hospital admissions with about 57% of the total burden. And pneumococcal disease, which is vaccine preventable, accounts for about 40% of these admissions. We also have to remember that the pilgrims who go there are mostly older pilgrims. The majority are over the age of 50, and over a third of them have some comorbid conditions, which makes them more susceptible to pneumococcal disease. And this is a South African study of 2018, just elaborating on that data. For example, during the Hajj of 2018, 65% of South Africans had some form of illness, of which 70% was respiratory related. But also on the return, 40% of South Africans had some form of illness, of which 80% was respiratory. So when we look at the data, and this is a couple of meta-analyses that were done, it was found that influenza vaccination is significantly associated with a reduction in prevalence of influenza-like illness. And this benefit extended not just to the program themselves, but also to the possibility of them carrying certain strains back to the countries of origin. And so we strongly advise influenza and pneumococcal vaccines in those the pneumococcal vaccine, obviously, in those who are susceptible, such as the older age group. I think Professor Sipho Dlamini already gave a talk on that. Now, when we talk of older travelers, and I'll marry the two now, we know that by 2035 in the United States, those older than 65 will outnumber children under the age of 18. Now, of course, we know about immunosenescence. We know about pre-morbid conditions that can increase the older person's susceptibility to infections. But they have more disposable income. They travel in groups and they travel for longer periods. And just getting back to the Hajj, in Turkish pilgrims, for example, more than 52% of them in the year 2018 were over the age of 60. And generally, over 50% of Hajj pilgrims are over the age of 50, often with other comorbid conditions. So we have guidelines available for pneumococcal vaccines. But I've often talked about people traveling to the third world countries, but even travelers going to first world countries, you'll notice that the commonest pathogen, the commonest illness picked up are respiratory ones, like pneumonia, like influenza, and again, these are vaccine preventable. So let's look at some of the larger sports events. And again, if you look at the FIFA, let's first look at the World Cups for soccer World Cups. No major incidents have really taken place except increased travelers' diarrhea in certain cases, influenza-like illnesses. But again, these have not really been well documented. If you look at the Olympics, 2016, there was actually a call for the Olympics to be called off because of the possibility of Zika. But again, there's often cases of infectious diseases such as gastrointestinal that have been documented and increases in upper respiratory tract infections. And this Olympics that just took place in Paris, for example, there was a big concern about dengue because dengue is increasing rapidly in Europe, and there is a vaccine available for it currently, but there wasn't an outbreak. Similarly, there was a concern about the river Seine that was quite badly polluted, concerns about infectious diseases, gastrointestinal problems. Again, there wasn't really a pickup of it. The FIFA World Cup, and this is not published yet, but this is data that we received from the person who was in charge of the medical side there. About 9% of cases that were seen were upper respiratory tract infections. I want to briefly talk about COVID and just give two examples of it. The first one is what often is called KM0, and this took place in Italy. Atalanta, which was a local club, versus a Spanish club called Valencia. And they were mostly locals there, 44,000, but there were a couple of Spaniards there, 2,500. And this was the biggest game in Atalanta's history. Now, you people know the Italians. They won 4-1. But what happens when they score a goal? They embrace each other, spreading pathogens. They shout at I wonder what would have happened if the score was 10-0. They shout when a goal is scored, spreading pathogens as well. And 2 days after the match, the first case of COVID was documented, and about a third of the Spanish players also tested positive a couple of days later. And football matches led to an increase in infection rates in that area of 500%. A similar issue was found during the Euro Football Cup in 2020, which took place in 2021, sorry. And just to show you, this was a game that took place in London. Scottish fans went to London to watch this match. About 2,600 of them went there. And a couple of days later, this is in Scotland, you'll see the lighter colored one depicts the the guys who actually went to go watch the match, mostly males, and the black color is those in contact with him. So about 4% of the total Scottish number of COVID cases could be related to the soccer matches that they attended. Something similar was documented in Spain. Football matches, basketball matches, and Women's Day marches were all associated with increase in the number of cases of COVID. And I just want to go back to the Kumela of 2013, which is, like I've mentioned, over 150 million people attended over a period of 55 days. It's not playing. And in one study of over 400,000 patients, upper respiratory tract infections were noted to be the commonest presentations there. But also, during the time of COVID, and this is India 2021, returning pilgrims from the place called Haridwar were probably took COVID-19 back to their places of origin and probably caused the largest super spreading event during the COVID pandemic. And to put it in perspective, May the 8th in India had about 400,000 daily cases of COVID. This was 2 weeks after the Kumbh took place there. And it could clearly be linked to it. And these are the type of crowds that you see at the Kumbh. Next year, we're anticipating 250 million people to attend the gathering. And we know that the Ganges is probably the most polluted river in the world. And infectious diseases obviously is a concern there. But take a step back. We're looking at it as medical personnel. What does the pilgrim look at it like? To the pilgrim, the water is dirty, but the river is pure. So we need to bear that in mind before we criticize policies that are in place. Okay. So now we're looking at post-COVID, and we know that COVID, we had a resurgence of measles after COVID, because I consider it to have been the perfect storm. There was a mistrust in vaccines. There was vaccine hesitancy. There was a lack of access and availability to the vaccine. We know that measles is highly infective. We know that because there wasn't a good enough uptake, there was a lack of herd immunity. And after COVID, vaccines started to take place. Gatherings started to take place. And just one case I'm going to mention quickly, and this is gatherings started taking place in Zimbabwe, for example, where there was poor uptake of measles vaccines. And there were 704 deaths by the 6th of September, 2022, because of a purely vaccine preventable disease. These are deaths that lives that could have been saved. Lots of other gatherings that showed that these are all vaccine preventable as far as measles are concerned. I'm not really going to talk about that, but I want to talk about meningococcal disease. And we know that for the Hajj, it's always been a mandatory requirement. And again, I want to talk about meningococcal disease having a high impact, even though the incidence might be low. Now, when it comes to the Hajj again, people come from 184 countries and converge in one place, but they go back to the countries of origin. We all know about the meningitis belt. We had a talk about it yesterday. Now, in 1983, there was an outbreak of meningococcal disease in Nepal. Pilgrims going to the Hajj carried it to Pakistan, and by 1987, they've carried it to the Hajj, and returning pilgrims to sub-Saharan Africa took it back to their countries of origin, so that by 1989, there were outbreaks in Ethiopia and Kenya as well. 2020 and 2001, there were outbreaks also of this time around, pilgrims brought it from sub-Saharan Africa, took it to the Hajj, and returning pilgrims took it back to countries, causing outbreaks in 14 different countries, from the United States in the west to Indonesia in the east. And carriage has been noted to be up to 80% amongst the pilgrims. But with the vaccine, there was virtually no cases in the last couple of years, except last year when some unvaccinated people went and actually had the disease there, because fraudulent cards were still issued. I'm not really going to talk about this one, but I just want to talk about meningococcal B, because there was a musical festival in Australia in 2022, attended by about 40,000 attendees. And there were 4 cases of meningococcal meningitis serogroup B there. And even though we know that it's mostly youngsters who are affected, the person who died during that outbreak was a male of 40 years old. And unfortunately, the vaccine is not currently universally available. Serogroup B meningococcal disease, we're worried about because this vaccine is not easily available. But again, I want to go back to the fact that previously the vaccine to Saudi Arabia was mandatory. You couldn't get a visa, which you had to get at the embassy previously, without proof of vaccination. This year, visas could be obtained online, and a lot of people decided not to take the vaccine. And then we had an outbreak of at least 12 cases of returning pilgrims. But what's worrying here is that 10 adults had the disease, and all of them were unvaccinated, and this was serogroup B, serogroup W. But one returning pilgrim gave it to 2 children in the United States. This person was asymptomatic, but still carried the pathogen back. He wasn't vaccinated and caused disease in 2 of his contacts in the United States. Also want to again emphasize the connection between invasive meningococcal disease and influenza. Influenza seems to stick its head out everywhere. In Canada, for example, a doubling in invasive meningococcal disease incidence, it is a doubling of it per 100 case increase in influenza A activity. Susan Mayron also wrote a good article on that, where it was shown that up to 9% of the IMD cases in South Africa could be attributable to influenza co-infection. Anyone knows where this is? Yeah, it's 9.5 million going to Moria every year, at least. This is a Zion Christian church in South Africa. Again, mostly youngsters going for a short period, and it's one of the largest annual mass gatherings on earth. And we don't have any documented cases of infectious disease outbreaks, but we always have the concern about cholera, typhoid, and respiratory infections. The Arba'in, like I've mentioned before, 20 million people in 2022 gathered there. And this is a fascinating mass gathering because even though about 20 million people attended, 2 to 3 million people walk from Iran, and they walk up to 600 kilometers just to get there. And lots of studies have been done there about most of the infections that's documented are respiratory ones. A lot of people are older. So again, we emphasize influenza vaccine and pneumococcal vaccine, sorry. This is a Bijwa Ijtima. This takes place in Bangladesh. This is on the outskirts of Dhaka in a place called Tongi. Not good data about what is seen there, but sporadic reports talk about quite a lot of infectious diseases. And these include hepatitis A, hepatitis B, cholera. All of these are vaccine preventable ones. Then one of the largest ones that takes place is the Basilica of Our Lady in Guadalupe. There's a Catholic pilgrimage which takes place in Mexico City. An apparition of the Virgin Mary is claimed to be imprinted on a cloth that's actually stored there. And 11 million people attended it in a week's period in December of 2022. Again, mostly locals. Lots of dengue is encountered there, lots of GIT conditions, but not good data is available as to specific pathogens. This one is in Senegal. This takes place in a place called Toba. 3 to 5 million people go there on an annual basis. And again, there's a large study of 32,000 consultations. 5% were gastrointestinal presentations, and 5% were respiratory tract infections. Sexually transmitted diseases and mass gatherings, as I've alluded to it already at the Olympic Games. Now we know that about 1 million STDs are acquired annually, and travelers are at high risk for unprotected sex. And over 20% of travelers have been documented to have casual sex with new partners. In one study, it was actually over a third of them. Condom use varies between 25 to 75%. And this has been linked to the spread of multi-drug resistant pathogens, and there'll be a talk on that a bit later. So in those cases, human papillomavirus should be considered. When it comes to monkeypox, initially it was associated with mass gatherings. We know about the Spanish, the Pride mass gathering that took place in the Canary Islands in May 2022, which was attended by over 80,000 attendees. And there were 73 cases from Spain alone that were documented there. And even though initially it was mostly men having sex with men, lately we all know that the nature of the epidemic has been changing, because cases even that time were identified where there was no sexual contact, but there was close contact between people, physical contact. So again, if we go back to the Kumela that's planned for next year with in 2025, 250 million people in 55 days, massive crowds, close contacts, there is a concern about monkeypox. Okay, and my final topic is going to be on Gaza. We're going to talk about polio here. Gaza was polio-free for 25 years. They had a good, robust immunization program. There was strong vaccine acceptance. There's been involuntary mass gatherings, really, since the war started in 2023. And there's been the re-emergence of polio since in this year. And even though the WHO is having a mass vaccination attempt, there is concern as to what's happened further. Anyone knows who's Paul Alexander? Was it mentioned? He died this year. Does this ring a bell? Yes, okay. He contracted polio at the age of 6, and he was 72 years in an iron lung. He said polio can come back again. It is important to know what this is and what he had to live with. This is from his book, 3 Minutes for a Dog, My Life in an Iron Lung. Again, vaccine, you cannot describe this other than a mass gathering. We know there's GIT infections, respiratory infections, hepatitis A, all of them are vaccine preventable. There's other issues with this as well, because returning Israelis some of them have died because of multi-drug resistant infections. And so it's not only the Razans that are being affected, it's actually everyone who's involved in the WHO have actually noted that disease could be even deadlier than the airstrikes. These are yellow fever endemic areas. These are dengue distribution areas. Those are the isotherms between which you find dengue, Zika, chikungunya. All of them have vaccines available nowadays, but except for yellow fever, none of them are available in South Africa. So when people travel, especially to mass gatherings, talk about mosquito bite prevention, because these diseases are spread by mosquito bites. I'm not going to talk about hepatitis A, which can be contracted at mass gatherings, neither about typhoid or about cholera, because they've been covered already, but we have to bear in mind that they will, travelers to mass gatherings can be confronted with them, depending where the mass gathering is. Travelers with high-risk conditions should also be considered to be susceptible when they're attending mass gatherings and be counseled about which vaccines to take, as well as travelers living with HIV. I mean, we know that, for example, even if someone is on ARVs who's living with HIV, they are 42 times more susceptible to invasive pneumococcal disease than those who are not living with HIV. I'm sure Albie gave you some travel vaccine resources. And if anyone is interested in religious mass gatherings, we just put out a paper called Sacred Journeys and Pilgrimages. It's available free on the Journal of Travel Medicine website. So in summary, I want to say that mass gatherings have the potential to seed epidemics and pandemics. Infectious diseases are not very common at mass gatherings, but as in pneumococcal outbreaks, as meningococcal outbreaks, and the COVID-19 outbreaks have confirmed, they have the potential to cause devastating effects. Vaccines have proven public health benefits, and they should be used as a public health tool at mass gatherings. And each mass gathering should be considered as this event at this time, at this destination, attracting these attendees. And of course, it should be the vaccine should be appropriate for each mass gatherings. And it's probably time for us to have a think tank about what should be advised to potential travelers. Travel pearls, just want to say that wash your hands, don't smoke, use condoms if appropriate, cover your cough, vaccinate, and if traveling to a malaria endemic area, use prophylaxis and avoid mosquito bites. And my final slide is about what is really the geniuses who go to Google, Professor Google every time, because this came out a couple of days ago, and this is what we are always thrown back at. If you look at polio numbers, up till 30th of October this year, wild polio virus caused only 64 cases, and last year it only caused 10 cases. Vaccine-derived polio this year is 195, and last year it caused 342 cases. So clearly, it's better not to take a vaccine than and rather be exposed to the rest of the world, because the numbers clearly show that you have a higher risk of getting polio if you are vaccinated, if you purely look at the numbers. So I think we've got to be aware of what's out in the public domain and use what knowledge we have to advise our travelers, especially if they're going to mass gatherings. Thank you, and I think I finished on time. Okay.
Thank you very, very much. We're going to start with, nope, we're not. Okay, questions. You provided all the information. Any questions? And from online? Oh.
Hi, thank you very much for your presentation. I feel very nervous as somebody who travels in and out of the country quite a bit. I'm just wondering what the recourse is for regular, let me speak as an academic. So we always go for these conferences or this and that and moving in and out. How seriously should we take vaccinations, for example, like malaria? Like I'm originally from Kenya, but I live here. And it was not a problem because I lived in Nairobi before, but it seems the last time I wanted to travel, I was advised, maybe you need to be vaccinated for malaria. And I was like, I don't know, how does that work?
Okay, as far as malaria is concerned, after a year, most people lose their immunity to it. That's well documented. So we often have people going, moving to the United States, for example, from Ghana, and after a year or two, they go back to visit. I've been living there all my life, I'm going back. It's been documented that they can actually contract malaria. So if they go back for short periods, we advise chemoprophylaxis. Vaccine has not been licensed for adults, so I don't think it comes into the equation at the moment. But there's clear evidence that once you leave the malaria area, your innate immunity decreases substantially, and after 2 years, you are considered probably not immune susceptible. Yeah. Naive, that's what I was looking for, malaria naive. Okay.
And one question this side.
Thank you very much. It's fascinating how you show us the crowding and all the gathering that happened. I have a curious question with regard to Hajj. You were saying that with e-visa, people do not have to take a vaccination. In my lame understanding, I thought when you reach the airport, the administration is supposed to check your vaccination card end your visa before allowing you to enter the country. Is it because this is not done, that is why those diseases are spreading, or is because they are carriers? Thank you.
Previously, and again, this has been well documented, previously there were fake cards. It was easy to issue fake cards. We actually put quite a big contradiction. You're going for an affirmation of faith, and yet you're prepared to fake something. And this was before vaccine hesitancy. But lately, it's because the embassy is not issuing it. You get the visa online. Now, yes, they're absolutely supposed to check it online, but imagine there's 10 plane loads landing at the same time. I, for example, have been going for the Hajj for the last 24 years. My card was checked twice, but on both occasions, I was traveling with a big group. And if one of them didn't have the card, the whole group gets put behind and gets taken back and actually vaccinated on the site. But the other years, nothing was checked. It just depends on when you arrive and the person who's actually the port authorities who are on duty at that time. Some of them are very vigilant, others are not.
Okay. I just want to mention that the online participants are very happy. They're saying your presentation is very informative. And we have one question from Tambe. He's saying, considering mass gatherings, what measures should the states or the state authorities take in such situations to prevent infections?
Again, it's, there's a couple of practicalities involved. For example, let's use the Hajj because there's a lot of literature on it. It's easy to say that 90% of people get respiratory tract infections. So let's make the influenza vaccine mandatory. It takes place in Saudi Arabia, which is the northern hemisphere. There's no vaccine available during their winter for us. In other words, the southern hemisphere people will not have an influenza vaccine at the time when the Hajj takes place. Second issue that's a problem is something such as pneumococcal vaccination is hideously expensive. The drug companies can jump down my throat, but the reality is that most countries can't afford it. So that's why that's not made mandatory. The meningococcal vaccine is relatively affordable. Plus, there's good data to show that it is dangerous. I mean, it can cause epidemics. So that's why they make that one mandatory. And similarly with yellow fever, it is known that the Aedes aegypti mosquito is in Saudi Arabia, so they can dictate that anyone who comes from a yellow fever endemic area must have that vaccine. So it's a cost issue, it's an availability issue. And what we, from a South African perspective, are concerned about is that next year, they're demanding that the latest COVID vaccine is administered before pilgrim can actually go for the Hajj. We don't have anything available in South Africa. In fact, I had a poor youngster who had a good job available in Dubai, but part of the job requirement was to get a COVID vaccine. So she had to take a holiday to Dubai, get a vaccine, come back home, send the proof of vaccination to Dubai again, where she just was, and then only she could get the job. So this is the reality that we're sitting with. So we've written to the Saudi authorities to say we don't have COVID vaccines available. They must either exempt our country or they must change that law. So the countries are taking measures. So, okay. This one.
Over there.
Thank you very much, sir. So I just want to seek some clarification regarding the Hajj, because I think you mentioned that the influenza vaccine is part of what the recommended vaccines that we have. And I know that at least my country, Nigeria, is not part of recommendations when you're going for Hajj. You get the yellow card that has the oral polio and then also the meningococcal. So is it impossible to mandate the Saudi authority to include because of course people pay to go for Hajj and it's a source of revenue for Saudi Arabia. Yeah. So it's not possible that they're able to look at it and see when people come into their country, they make some of these vaccines available. If it's part of the package that they're going to pay for, it's going to also protect the people that are coming for the Hajj and also protect their country. Is it doable thing?
They've looked at especially influenza, but because of seasonality, because of production, for example, it would mean South Africans are going to the Hajj next year. I'm just using that. We from the Southern Hemisphere countries, we don't have the required vaccine available yet. There's a 6-month lag between the two periods. So that's why they cannot mandate it. Secondly, it's not always available in every country. Influenza vaccine, this is again the industry thing. They will supply to where there's a demand. If a country doesn't have a high demand, there's not going to be a supply. And if it's there, if you want to have a Section 21, in other words, you want to apply for it without it being registered as such, the process is quite tedious. So that's the reason. There's been a lot of pressure on them to make it and pneumococcal vaccine compulsory in the elderly, because they've done the cost. It cost them quite a lot of money to hospitalize people, with 39% of them with pneumococcal disease, for example. I mean, those sums are quite high, but they cannot mandate it because it's not all easily available.
Thank you so much for providing us with really valuable information. Are there questions online? No. Okay. Thank you very much. Okay, we need to shake the sillies out. We've got one more talk before lunch. Dr. Eloise du Toit is speaking to us about a really important topic. My history is pediatric ICU nursing. I have looked after children, and antimicrobial resistance is devastating in an ICU. And it took me working in an ICU to realize that we need to prevent people getting there, we need to prevent children getting there, and we need to prevent them dying. So, Dr. Eloise, please come up.
Hey everyone, good afternoon. My name is Eloise du Toit, and I'm a microbiologist, and I'm here on behalf of the Global Antibiotic Resistant Partnership, which is part of the One Health Trust. I would like to just put a disclaimer out there that I am not very well informed on vaccinations and immunizations, and in the field of them, and actually attended this course 2 years ago to get a bit more information. And since then, Ben and a couple of other colleagues in the room have actually worked quite closely on a couple of projects as we continue to learn how important the link between AMR and vaccines are. Okay, so my talk is going to give a brief outline on the health burden of AMR, and then speak about how we can leverage vaccines to reduce AMR. I'll show some selected evidence that the One Health Trust and GARDP have put together, mostly using the limited data that is available, and then modeling. And then I will quickly speak about the GARP, which is the Global Antibiotic Resistant Partnership Overview, and then conclude for lunch. So AMR is a global problem, and it occurs when microbes adapt and resist to their current therapies. So when antibiotics are effective, they can prolong life, reduce disability, limit healthcare expenses, and enable many life-saving medical innovations. I hope to cover what AMR is and start to unpack the full economic evaluation of vaccines when it comes to AMR. Antimicrobial resistance is often referred to as the silent pandemic or the overlooked pandemic. And this is because people often don't think about it, or they perhaps don't understand the enormous burden that it carries. And this might be because it's not applicable to one disease. It's applicable to many diseases, infections, communicable diseases. The AMR pandemic is at the stage now where antimicrobials have lost their effectiveness. So much so that there's even been a documentary made on it, and I've put the link there should anyone be interested in watching it. So AMR results in increasingly difficult to treat infections, increased morbidity and mortality. And as an example, a patient with a drug-resistant infection has an 84% higher risk of mortality and a 50% increased risk of hospital readmission. It has recently been reported that when looking at bacterial-related infections and deaths, global annual deaths, thanks to bacterial infections, account for 7.7 million deaths. Of those that are associated with AMR, that amounts to 5 million deaths. And of those, there are 1.27 million deaths that are directly attributable to AMR. AMR is also hindering our progress in achieving our sustainable development goals, especially on child survival. The graph on your right shows that without AMR, we would be able to reach our targets by 2030 more quickly. And who is affected? Well, absolutely everyone, even if you have never taken an antibiotic. However, it does unfortunately affect the vulnerable, such as the very young, the very old, the severely ill, and those, of course, in resource-constrained settings who don't have access to clean water and sanitation, as well as limited treatment options. This diagram I would like to illustrate that AMR, the burden is the highest in low-income countries. You can see on the left that the amount of AMR-related deaths are highest in sub-Saharan Africa and South Asia. The image on the right, in a way, is a mirror image of that, where this was a study showing the rate of vaccinations or zero-dose vaccinations and incomplete vaccinations, and they used the DTP vaccination as a reference for this. And you can see that the bars right on the left of that are the highest, meaning that the number of zero-dose and incomplete dose children are highest in Africa and Southeast Asia. So you can see that where AMR is highest, the rate of vaccination is lowest. So when we look at the biology of AMR, just to explain very briefly, this is when bacteria change and they become resistant to the antibiotics that we use to treat them. So in the top row, you see a susceptible infection. You treat the infection with a first-line antibiotic, and over a few days, the infection is cleared. However, with a resistant infection, you give the first-line antibiotics, and you still have the infection. You give the second-line antibiotic, and you still have the infection, and you give a third-line antibiotic. And this is now a growing problem where the third-line antibiotics are becoming even more ineffective. And how do bacteria do this? What is the mechanism of AMR? So when an antibiotic is effective, it has several mechanisms to which it can kill the cell. And this involves targeting either the bacterial cell wall or structures within the cell, such as nucleic acids or peptides, which are used for protein synthesis. However, on the right of this diagram, when the cell develops antibiotic resistance, it can result in the cell having less ability to uptake the antibiotic, so it has decreased drug uptake. It can alter the drug target within the cell. It has efflux pumps that can pump the antibiotic out of the cell so that the desired concentration of antibiotic is never reached to kill the cell. And it can also inactivate the drug. So what are the drivers of AMR? Well, there are numerous, but I think that a very good general foundation we can say is infectious diseases. So infectious diseases result in antimicrobial use, which then in turn results in antimicrobial resistance. And this is where vaccines come in. Vaccines can step in before the infectious disease occurs. A good example of this is the introduction of the PCV13 vaccination. It was introduced in 2010, and you can see a concurrent significant decrease in the amount of antibiotic-resistant cases between 2009 and 2013. So vaccines can prevent infections in the first place. They reduce primary and secondary infections. They reduce the transmission of resistant strains, and they reduce antimicrobial use. The Lancet series in antimicrobial resistance, which was published this year in May, showed that several well-understood interventions can significantly reduce AMR in low and middle-income countries. So improving your IPC standards, access to WASH services, and specifically for this talk, getting universal coverage for the high-priority pediatric vaccines can reduce 181,500 AMR deaths. So apologies, this slide was actually moved a little bit further down, but I'll speak to it now. Just to get an idea of the economic burden of AMR, the unfortunate situation is that data is very, very limited. And so to try and get AMR into the considerations in the vaccine policies has been difficult. However, more and more studies are being done on the available data, as well as using advanced modeling techniques. And this is such a study that's a systematic review published recently, and they show that the highest vaccine avertable AMR burden is in Africa and Southeast Asia again. So this is where you can really get your most bang for your buck. So in 2022, the WHO acknowledged the importance of AMR vaccines in reducing AMR, and they've put together an action framework. This action framework is now in the position of being implemented, and that comes with significant challenges. I now want to show you some evidence, mostly on using modeling data. And I'll first speak about the available vaccines and then the hypothetical vaccines. So starting off with the childhood PCV 10 and 13 vaccination. These images show on the left-hand side a situation where there is no vaccination. The middle is the 2018 coverage, and then on the right is the universal coverage that has been forecasted for in the future. And you can see that under the 2018 coverage, 23.8 million cases were averted. And then if we do reach universal coverage, 45.5 million cases can be averted. The same goes with the rotavirus vaccination. And so this also, I would like to highlight that this is, the vaccines are also important in AMR, even though they target a virus. So the rotavirus vaccination reduces infections and antibiotic consumption. You can see again that with the 2018 coverage, 13.6 million cases were averted. And if we reach universal coverage, 32 million cases will be averted. And this means that AMR or antimicrobial use or misuse, and that will be reduced. So speaking about the maternal RSV vaccine, this was shown to reduce antibiotic prescriptions by 10.9%. And specifically against the lower respiratory tract infection antibiotic prescriptions, they were lowered by 12.8%. The influenza vaccine, 11,153 antibiotic prescriptions can be averted by vaccinating 30% of the population 65 years and older. almost 8,500 antibiotic prescriptions can be averted by vaccinating 30% of the population under the age of 5 in Ghana. And almost 14,000 antibiotic prescriptions can be averted by vaccinating 30% of the population between 2 and 5 in Senegal. Talking about the malaria vaccine, this slide is showing on the bottom row, the number of averted cases if you have the malaria vaccine at a 40% efficacy. You can see that 235 cases could be averted per 1,000. You can avert 0.6 resistant cases per 1,000 and 0.6 averted deaths per 1,000. So the typhoid conjugate vaccine can reduce drug-resistant cases and deaths. When looking at 73 countries eligible for Gavi support, the routine use of the TCV and a catch-up campaign at 15 years can avert 66.7 million cases of typhoid fever. And for individual countries, the avertable burden ranged from 46 to 74%. And the majority of those I'd like to show here, not the majority, but a third of those cases will be in sub-Saharan Africa. So now to move on to vaccines in development. The potential maternal Klebsiella pneumonia vaccine, which may reduce neonatal sepsis cases and deaths. So assuming a 70% vaccine efficacy, 14.91% of neonatal sepsis deaths can be averted annually. Almost 400,000 neonatal sepsis cases averted, cases averted annually. And 3.4% of the neonatal deaths can be averted annually. And of course, the greatest benefit is to be expected in Africa, and especially in sub-Saharan Africa. How about a post-exposure TB vaccine, which can reduce resistant cases and deaths? So in 30 countries, an M72-like vaccine with 50% efficacy could avert 10% of the RIF-resistant TB cases and 7.3% of the resistant TB deaths. So my take-home message here is that vaccines can mitigate AMR. So AMR is a huge problem that is responsible for more deaths than HIV, TB, and malaria together. And just a quote that I found on from the One Health Trust: vaccines help reduce the burden of antimicrobial resistance and the need for antibiotics, but vaccine coverage needs to be scaled up, and new vaccines are needed to tackle both resistant bacterial pathogens and the viral infections that trigger antibiotic prescriptions. I now want to talk to you about the organization GARP, which, as I said, falls under the One Health Trust. This is an initiative that was started in 2008 and is in 15 countries around Africa and Asia. They support, that's a group of interdisciplinary experts, and the aim is to increase visibility and elevated AMR in the political agenda. They have been involved in the development of national action plans. And these are the representatives of the South African Technical Working Group of GARP. We have multidisciplinary people with different expertise. And the group managed to publish a perspective paper, which has recently been published in the South African Medical Journal, where we spoke about the barriers, facilitators, and strategies of how to really incorporate vaccinations in the fight of AMR. So to conclude, vaccines are a very important tool to decrease infections and antibiotic prescription and use. Modeling data for antibiotic resistance is a good metric to use when considering the value of vaccines and their added benefits. The costs associated with AMR are high, and treatment is not always available, or is expensive, or is not accessible. So everyone would benefit from this collaborative AMR immunization partnership. So
Thank you very much. That was incredibly informative. I'm going to see if we've got any questions from the floor.
Thank you very much for. Yeah, thank you very much for the presentation. So I have a question. I don't really know if I'll put it right, but I want to know, like, for example, in Cameroon, I'm from Cameroon, so we have a lot of people who buy medication in local stores, like not in pharmacies. It's the usual. So, and then we have issues like malaria and typhoid that is reoccurrent, and they're exposed to environments where even if they treat themselves, they still get, to be sick. And most often, even the prescription is not by doctors. They already know what they want, so they just go and they buy. That's a problem. And another issue is, could the reoccurrence of the illness be due to the fact that they are exposed to that environment, or is because there's already the resistance of the infection, and what then can be done, to help those people? Is it because, they're exposed to the environment, or because it's just like their system is already resistant to the infection? And is there any solution, for that?
Yeah, so I think, I hope I understood the question correctly. And I think that this is why organizations such as GARP and the One Health Trust, as well as many others, are really focusing on antimicrobial resistance and the problem that it poses. Because this is the problem that is happening, and especially in low and middle income countries, where there is perhaps a lack of regulation of antibiotic use, or they are access to antibiotics is not optimal, so they don't have the correct antibiotic, for example, or there's just many, many, many reasons. And I think that this is why people are trying to make AMR such a kind of hot topic. So I'm sorry, I'm not sure if I answered your question exactly.
I think your answer is more about prevention, but what of those people who are already in that stage?
Oh, who are already resistant?
Yeah, and there are a lot of them, because malaria and typhoid is really reoccurrent in Cameroon, and people are just like buying in those stores. It's the usual now. So
yeah. Yeah, and I think that the problem with the development of new antibiotics is very, very slow. And so unlikely. And so I think at the same time as the slow development of any new antibiotics coming onto the system, I'm not exactly sure what you can,
thank you.
Can do.
So
Carry on
it's just a concern.
preventing.
Thank you.
Yeah.
Thank you for the presentation. I have two questions. The first one is that you mentioned earlier that where AMR is highest, the rate of vaccination is lowest. So I want to understand that, do you not think that the best way to approach this is not really to focus on manufacturing of vaccines, but to really focus on improving, for GAP and One Health Trust, to focus most of their efforts in helping to improve vaccine coverage in some of those areas where the coverage is low?
Absolutely.
And the second one is looking at the rate at which AMR is gaining momentum, because to me, it's really gaining momentum. Do you think there's enough work being put in to AMR to really match the momentum that it's gaining at the moment?
So thanks very much for that. And yes, I think that one of the main goals of these organizations is to improve coverage and access to vaccines. But to do with your second question, no, there's not enough being done. And actually, because since the WHO has acknowledged the problem of AMR and really made it a priority item, they have put out they've actually requested that countries come up with national action plans on how to deal with AMR. And that includes surveillance and improved diagnostics and all of these things. But the problem is countries are having their national action plans put together, but the implementation is incredibly difficult. So that's the problem at the moment, that people have the document, the NAP, but what to do with it, the implementation of what's in there. And that could just be, that could be manpower, it's financial reasons, it's a lack of political will, because as I said, it's a silent pandemic. And so do governments actually realize that it should be, take priority up there with TB and HIV? And I don't think it's there yet.
Okay. We have an online question. So this question is from Gabriel. He's saying, thank you for a very interesting presentation. And his two questions are as below. The first one is, how can new vaccines be designed to target multi-drug resistant organisms? And are there specific characteristics that make certain bacteria or viruses more suitable for vaccine development against AMR? And then his second question is, what are the economic benefits of investing in vaccines targeting AMR compared to the costs of managing drug-resistant infections, and how can this be communicated to funders and stakeholders?
So I think that to go to your first question, how do you target, which disease or pathogen do you target to develop a vaccine? And I think the approach that GARP has taken, at least, is that it has to be country specific, because countries will suffer from different diseases at different levels. And so they actually need to have a priority list put together of what they think are the most important diseases to target with a vaccine. And then the second question was the financial input for developing new vaccinations versus the burden of AMR. Yeah, so I think that, I think it goes back to the old saying of prevention is better than cure. I think that the implications of antimicrobial resistance, it's, as I said, the disease is actually becoming more and more difficult to treat. The costs incurred at the hospital for the increased stays and the readmissions are enormous. And then basically the main outcome is death. So, with these antimicrobial resistant bugs, if we don't have something to treat them, so I think that it is definitely worth a financial input to develop new vaccines.
So I think his last part of the question was, how can then this be communicated to different funders and stakeholders?
Yeah. Yeah, I guess that's what we're trying to do. Yeah.
Thank you very much. It's really a good presentation. I would take from here. So I would like to know, what is the first factor that in sub-Saharan Africa, non-South Africa, that is really have a higher prevalence of AMR, antibiotic resistance. Secondly, is this vaccine that is produced is going to be free, like those vaccine in immunization, or is it going to be a charge? Because in this room, fewer countries reach the universal coverage of health, public health. In Chad, you need to pay. Even for consultation, you need to pay. So the reason why those people go to buy the medication that is not efficacious is because they don't have money. Now the government, they don't take into consideration how to lower. What is the role of the NGOs that are supporting government to assist in lowering those costs of effective medication in order to limit those resistance? Thank you.
Thanks for the question. So to do with the levels of AMR in Africa, it is quite difficult to dissect exactly because the data is very limited. So a lot of the data that's presented and that is reported and used is based on the little data that is available and mathematical modeling. So it's difficult to say which country. I would say outside of South Africa. Yeah. And then for the second question, I wonder, so were you talking about antimicrobials or vaccinations when yeah, antimicrobials, the access to antimicrobials. So again, the access to medication is one of the I think that all countries who have a NAP, the National Action Plan, I think one of their items on the, one of their priorities is access to medication, access to medical care, access to water and sanitation. And that's what I said is the problem now, that people have got their National Action Plan, but the implementation of it is the problem now. So that's where we're sitting now. So we've got the document that says, people must have access and this, but the implementation is the barrier now.
The documents are there, but to be honest, you will see a document that is well presented, well documented. When you read, you are very happy. But you go to the hospital or go to the community health center, you don't even, sometimes simple Panado, you don't get it.
Yeah.
What is the role of the NGOs? Instead of investing in vaccine, can they sit down and then look closely how or what to do to assist to prevent these disease to antimicrobial resistance and cause of death? That is my point.
Okay.
Thank you.
So from the point of view of GARP and the One Health Trust, their objective is to spread the message and get policymakers on board, because without the policy and the political will, where will you get? So I think that the aim of NGOs such as GARP, that is their aim to. So basically, we've got that perspectives paper out that we really showed quite excellent evidence of the use of vaccines to prevent AMR. As well as what barriers we can foresee. And the next thing we want to do is then produce a policy brief, which is about to come out. And we're hoping that that will, it's just more information to try to encourage policymakers to realize the importance of AMR, and in that is how you prevent it. So yeah, so from the GARP point of view, it is to get the policy makers on board and make them realize how important this is.
Can I just make a point?
Yeah.
Your presentation was absolutely wonderful. I get the sense that I think people are thinking about that you need a vaccine for a bug and you need another vaccine for a bug that's resistant. No, you don't. Okay. You need a vaccine to prevent an infection
in the first place.
In the first place.
Yes, yeah.
And therefore, you're going to reduce the rate of infection in the community.
Yes.
And therefore, you don't need antibiotics to treat those infections, and therefore you will contribute to reducing antimicrobial resistance.
Absolutely.
Just to make that clear, because I think I get the impression that's come through in some of the conversation. Not from you, just from the questions. Yeah.
Sumia, you can go.
Thank you for your presentation, Eloise. It was really lovely and informative. I recently attended a infectious disease course module, and one of the speakers or one of the experts believed that one of the leading causes of antimicrobial resistance in South Africa, at least, was unsafe hygiene practices among healthcare workers. So I was just wondering, what is GARP's opinion on that, and what are some of the solutions to that in terms of developing policy briefs, or is there anything that they are currently doing in that area?
So you said that the thing was the lack of health, of kind of wash services for healthcare workers.
So it was a lack of hygiene practices of healthcare workers to their patients, that was the message that was being conveyed as the reason for a rising antimicrobial resistance issue.
Yeah. Was that Mark Mendelsohn by any chance?
Yes.
And I think that he speaks quite a lot about the HAPVAP, sorry, the infusion that you get, sorry? Sorry, I'm just gone completely blank, but I know that he really does focus on really limiting the amount of drips, IV, yes, thank you, yeah, IV drips, as a way, he has really recognized that, number one, I think he says that there's many IV drips that are, done unhygienically. Yeah, he's got some good stories, yeah. That's one of the causes of AMR. So as I said, it's preventing the infectious disease in the first place. So that is washing. That's unnecessary IV drips. It's it's a whole package, and so addressing all of that is at everyone's priority. So, and all of those aspects. So it's the misuse and overuse of antibiotics. It's unregulated antibiotic use. It's over-the-counter antibiotics. It's lack of sanitation. It's hospital stays. It's it's a huge thing, and so that's kind of also why the implementation of the NAPs are quite tricky, because it's such a broad kind of thing to target.
Okay. We have a question online. This question is from Gertrude. She's saying, thank you for the presentation. And if we take the example of tuberculosis with AMR, how can we assess the vaccination coverage and the vaccine efficacy of BCG, which is supposed to protect against TB and is mandatory at birth, and so far has good coverage?
So if I understood that question correctly, can I direct it to a vaccinologist, please?
Yeah, choose one.
Thanks. So to answer your question, if BCG was very effective, and we had a TB talk, I think on Tuesday, if BCG was effective in preventing tuberculosis, especially pulmonary tuberculosis, which is a big problem, then would not have a need for TB treatment. And in that case, would not be having resistant to TB treatment. But because BCG is only effective in preventing severe forms of TB, which you normally get in childhood, it doesn't prevent the big problem of the TB, which means that antibiotics are needed for the treatment of TB. So it is important, if you engage with communities and say, we talk about TB treatment and antimicrobial resistant to TB treatment, yet we do have a vaccine. The answer to that is yes, but the vaccine is not effective to prevent adult TB. We can only prevent childhood TB with that vaccine and severe forms of of tuberculosis. Okay, that's why development of effective TB vaccine is crucial. And we had about M72 TB vaccine, which is 50% efficacious, and it's showing that if it's rolled out, it would have huge public health benefits, including prevention of continuous antimicrobial resistance. Okay. Well, I've got the mic. Can I ask you briefly the question? It's more on the policy engagement, Eloise. And first, good talk. So you have mentioned repeatedly about the modeling evidence related to how modeling data is showing that vaccines can prevent AMR. How receptive are the policymakers and politicians on the use of modeling evidence for them to make decisions? And are there some of the studies you think can be done to generate sort of evidence that politicians and policymakers are much more accepting of as opposed to modeling? Thanks.
So very good point, Ben, because actually we had to be very careful in our wording of the perspectives paper and the upcoming policy brief, talking about the hypothetical vaccine. So you're right. I think that you have to be very careful with your wording and how you pass along a message to the policymakers. I wonder if it's due to this hypothetical data, this modeling data, that AMR implementation is not actually being implemented as urgently as it should be. Because where is the real world, the actual data? And so perhaps you and I can start a couple of studies. And I see Hannelie here. Yeah.
Short questions, sure. Sorry, now I think I'll follow up with Ben. I don't know if my question is to you or to Ben, so I'll just stay in the middle. So following up on your question, I think I want to ask, what is the effect of AMR on vaccine efficacy in childhood immunization? I'm asking that from context in Nigerian context. So when you have a woman deliver, culturally, they believe that you need to give them drugs home, take home drugs, even if they don't have anything wrong with them. So they go with because so many antibiotics and they just take it as routine. And they were going to administer childhood immunization. So my question is, I don't know if you understand, but the effects of, in quote, AMR on vaccine efficacy. Thank you.
So my answer is actually related to what Greg wanted to clarify. And maybe let me put it in a different way. So vaccines and antibiotics, the mechanism is very different. Okay? With the vaccines, you look for an antigen, even if it's a drug-resistant bacteria as an example. If you look at the right antigen that you put in the vaccine, then you train the immune system to mount an effective response. It doesn't matter whether the bug is resistant or not, because the vaccine will prevent the infection on that. That's why you need to vaccinate, create population immunity so that people don't get sick and they don't go to get antibiotics, which they don't need. All right. So in terms of the linkage of having resistant bacteria circulating, if a vaccine is effective, and it's not the case like for flu where we've got antigen changing. So if the vaccine is effective, it doesn't matter whether the bacteria is resistant or not. But you've got the issue of, SARS-CoV-2, for example, where you develop a vaccine for this strain, but there's mutation on the print, and then that changes. So that's different because immunologically, that vaccine is not going to be as effective because the virus has changed. All right. Did I answer you? Okay.
Okay. It is now lunchtime. Okay, but before you go, I have two thank you very much, Dr. Eloise. What you were speaking about obviously grabbed everybody's attention because there are so many questions and you're probably going to be hounded afterwards. Are there questions online that still need to be answered? There is one question online, so that you can just find Tabiso and she will give you the tablet if you can just answer that. After lunch at 2 o'clock is the think tank session. This whole room is going to be restructured, so everybody needs to take everything that is theirs away from their seating and take it with them to lunch. Then at 2 o'clock, when you are here at 1359, you will be here and you will break up into your groups for the think tank session and start your discussions. And then the whole room will be differently configured and everybody can start the think tank. Okay. Adina, did I say it all? Okay. Thank you very much. Go have something to eat, stretch those legs, and we'll be back for the think tank session. Goodbye.